think I should be live already. Hello, everybody. Welcome to Chloethedev Unfiltered. Um, Today, I'm going to be, or right now at least, going through chapter 2 of Vyper.fun, where we are going to continue making a Pokemon game. So I guess I should explain what that even is and what happens. So here you go through Vyper tutorials to create a Pokemon game. Get started. Cool. So you can go through, there's quite a few lessons now that I guess they're planned out. So you'll be able to eventually be able to do all this, but you can actually play through the entire game already. I guess I'll be going live later and testing through what you'll actually be able to build. But so far, the first 2 lessons are completed. So we're doing the second lesson today. And yeah, so we're just going to get started and pop into it. So, chapter 1, addresses. In the last chapter, we created Pokemons, but without any trainer to train the Pokemons, our game would be boring. Let's add trainers to the game. Each trainer would get a Pokemon by default. To do this, we'll need a new data type, address. So, in the first lesson, I guess last Monday, we went through creating a Pokemon, went through what a contract would look like, state variables, integers, a lot of the basics that you would look at in any programming languages. So Vyper would be, I guess, similar to Python. And so I guess you'd see a lot of these data types in most mapping, structs. And there were certain specific things that maybe to blockchain were using hash functions here, we had what do they call it in Vyper? I can't remember what they call it. Oh, for the mappings, they call it something different. They call it a hash map. Yeah, they call it a hash map instead of calling it a mapping. Oh, hey, welcome. So today we're going to be going through probably some more complicated things, but it's going to be fun. So in Ethereum, you have addresses, and that's the way you interact with other, I guess, users on the blockchain. So other people who are either Pokemon trainers, in this case, are going to be able to create Pokemon. But so the Ethereum blockchain is made up of accounts, which you can think of like bank accounts. An account has a balance of Ether, the currency used on the Ethereum blockchain. And you can send and receive Ether payments to other accounts, just like your bank account can wire transfer money to other bank accounts. So in Ethereum, though, instead of the transfer only being funds or money, it could be any data, it could be signing a transaction. So you can do lots of different things with your account more than just sending money. But it's definitely a good analogy of how to think of it that most people can understand. Each account has an address, which you can think of like a bank account number. It's a unique identifier that points to that account and looks like this. So it's in hexadecimal, so you can't really read it very well. But with things like ENS domains and other projects, I guess you have, what's that other one? Oh my gosh, I am blanking. But they're trying to do, a lot of projects trying to do like domain, I guess, have ways of bettering the way we do domain registry using cryptography. So this address belongs to the Vyper.fun team. If you're enjoying Vyper.fun, you could send us some Ether. So for example, this is an actual address. You can copy it to clipboard. Let's pop one out. Ooh. Go to Etherscan, and you could just see what's in the balance. You can see what's going on. They had a Gitcoin grant round. I ended up contributing. That's how I found out about all this. And you can kind of see, so it's kind of cool. And personally, that's why I got involved in blockchain, because you can just look at any project you like that quickly, which is super cool. Anyways, we'll get into the nitty gritty of addresses in a later lesson, but for now, you only need to understand that an address is owned by a specific user or smart contract. So we can use it as a unique ID for ownership of a trainer. When a user creates a new trainer by interacting with our app, we'll set ownership of the trainer to the Ethereum address that created the function. So nested mapping. So like I said, we learned about mappings in the last lesson. So how you kind of map a unique identifier to an address is you just use a mapping. So you map the address to the Pokemon. So now it's easy to know. So here you have the code. So you're mapping a trainer to a list of students. So teacher to students, you have a hash map. So say mapping a string of 32 characters, and you're doing a hash map of, I guess, how many students that, or no, the address of the teacher to the students list. Okay, so that's how, this is the function we got. So add student. Okay, so you are going to have teacher's name, and then the student. And then, so when you call this function, you take the variables of the teacher's name, the student, and then it's going to add, we got a roll number in there, and for the student name. So the teacher to students mapping maps the teacher's name of 32 characters to another submapping, which represents a list of students. This list of students maps student roll number. So now we have the roll number. Now we understand what that is, to their names again. So the teacher to students can be populated by adding two keys. The first key, so the key is just identifier to make sure you know what's going on. You don't lose track of what's happening. The first key for the 32 characters for the teacher's name, and the second key, which is going to be a number of unit 256 for the roll number. The value assigned is a 32 character for the student's name. Put it to the test. So now we're going to actually use it in Vyper. We're gonna go and put it for Pokemon training. So first, to create a trainer, we need to create a trainer struct. So again, now it's just assuming we know what's going on from all these data types. We're going straight for it. Here we go. Then to store the ownership of a trainer and their Pokemon, we are going to use three mappings. Create a trainer struct with a single property name of 32 characters. Then we're going to create a mapping, so a little hash map we went through, trainer Pokemon count with a key of address type and a value of unit 256. So again, we're going to be mapping the address to a number now. So now we could know, I guess, how many Pokemon trainers we have. So again, it's kind of no fun if we're not able to have the trainers and be able to interact in that way. Then we're going to create a mapping so we could, I guess, look up the trainers by their address. So trainers list with a key of address type and a value of trainer. Then, okay, so I'm going to be completely honest. Nested mappings always confuse the heck out of me. In Solidity, and I'm sure it will in Vyper, but we're going to get through it at some point. And luckily, we got a little solution down here. So at the end of the day, whatever happens, we'll get through it no matter what. Either way, we're going to create a nested mapping, trainer to Pokemon, with a key type of address. So that's going to be the trainer that we have on the Ethereum blockchain. So for example, if I was playing this game, I would have an address, okay? And it's going to map to another sub-mapping. So we're going to have a mapping to a mapping, which the sub-mapping has the key type of unit 256 and the value type of Pokemon. So what I'm assuming now is we're going to go to which Pokemon trainer you are. So that's the first hash map. So if, say, we have three Pokemon trainers, me, my fiance Bianca, and then we got Saini here as our third trainer. So that's going to be the addresses, and then we're going to map to which Pokemon we have here. So then let's look here to see if that even makes sense. So we have the Pokemon data type. See, I'll admit, this is a week ago. I just had Thanksgiving. Let's see. Let's make sure we can find and actually go through the code again and make sure what's happening. Let's just go through it from top to bottom, because honestly, I got to make sure I remember what's going on from last week. So we have our global variables up here, DNA digits, which is going to be a constant of unit 256, and it's going to be 16 max decimal places. Oops, sorry. Then we're going to have the mod to ensure that it actually stays at that digits, so that makes sense. So we're going to have, it's going to be a constant, it's not going to change. And this is where, again, I think where you get the power of Vyper, I would assume. So you have these variables that aren't going to be changing, and then now you know no matter what happens, these variables aren't changing in the contract, which I would assume. I'm sure you can do it in Solidity too. We're going to keep going. Then we have the HP limit. So I guess this is to ensure that no matter what happens, we're going to have a random number to create how much HP these Pokemon have. And you want to make sure that you have to have some, I guess, max limit on this number, I suppose. I mean, you don't really have to, but, to make it simple. And it's going to be 1,000. Then you're going to have a struct of Pokemon. So a struct is just going to be kind of like if you had like a human being, you wanted to create some attributes for that human. So same thing for Pokemon. So you'd have, for human, you'd have hair color, you'd have like, height. So certain attributes aren't really going to change. So this is kind of, or I guess they could change, but they got to have certain attributes. For the Pokemon, you have the Pokemon's name, which is going to be a 32-character string. You have the Pokemon's DNA, which is what we're kind of creating up here, which is going to be a number. You're going to have their HP, which again you have here, the HP limit, which is going to be numbered up to 1,000. I think up to and including 1,000. We'll check down there. And then, so here, now you have, I think, which was added, I think, in the last update of this game, you have how many matches each Pokemon's played and how many wins, which I think, personally, is super cool. Because, for example, I play Axie from time to time, and I think what's really cool about being able to track on the blockchain is the value of an asset or an NFT or so forth based on, for example, how many matches has this Pokemon won. It could be a very valuable data set to have. So then you're going to create your so here is where we're going to actually create this Pokemon trainer struct, which is the number one here. Then we have the data for the total Pokemon count for the total game. We have the Pokemon list, which is a mapping of what Pokemon what number Pokemon it is in the game. So you're going to start at Pokemon 0 and go up, and the Pokemon it is. So that's the struct right here. So you'll be able to look up this from this mapping and very easily know if let's look up for Pokemon 0. It'll show, what's Pokemon Zero's name, what's their DNA, and so forth. Then you're going to create your mapping here. So you're going to create your 3 mappings here. And then as new Pokemon, so this is kind of what we did last time, and I guess it's not too important, I suppose, for right now. But just quickly, as you create a new Pokemon, you're just going to get an event that goes off, or that you take out in the front end, taking the name of the Pokemon, DNA, and that's kind of what you get from here. Obviously, it's not going to have any matches or wins yet, so you wouldn't need that. Here's where you have your internal functions, and I guess we'll probably go through all that later on. So let's focus for now on trying to, trainer struct should be relatively straightforward. So I can't type again. Wow. Struct, trainer. So honestly, how I do it, I'm just going to copy this and try and make sure I copy the same format and try and get the same things as here. So we are going to copy there. And what I enjoy about Vyper over Solidity personally is that I don't have to worry too much about semicolons missed, and I can just use the tab button and it should work out. So with a single property, super easy, cool, name, which is going to be a string of 32 characters. Super easy. You don't have to worry about anything after that. And as long as you go to a different, as long as you go back to the beginning of the line, that's it. Super easy. So I'm actually going to remove this because when I look at the solution, it'll be easier if everything's on the same line for me personally. But this is where we're looking. And then we have to create our mappings. So we're going to start here. Create a mapping of trainer Pokemon count. So honestly, I don't know why I'm trying to type things out right now. Trainer Pokemon count. Okay. With, and then, so here you have to do, hash map. That's always, I actually enjoy the fact that it's named hash map. It's so much simpler. Like, okay, when I was learning mappings, I started my whole programming journey with Solidity because I was like, I just want to understand smart contracts, so let's just do it. It was not the easiest, but what it did, what really blocked me with mappings was that arrays kind of just made sense. Things were laid out, JavaScript, arrays, you go into things, object notation, makes sense. But once you get to mappings, you kind of have to understand like linked lists, and like when I started getting to like C programming, it made a little more sense. But before that, I think if someone just explained what a hash table was, and then explained like you're just linking data, I don't know. I just think the term hash map makes a lot of sense. So thank you for that little naming thing, because super simple to understand. So we're gonna hash map, and what are we mapping? Address type and a value of uint 256. So I always forget which way it has to go, but we're just going to go straight forward and assume it's straightforward. It's always backwards in my head. Is address like a variable completely in? Anyways, we're just going to keep going. And a type value of. So I think those actually might be switched around, and it might not be the right thing, but we're just going to keep going. Again, you don't have to put anything at the end. And then create a mapping of, actually just look up here to see if we're correct. So mapping maps a teacher's name. Yeah, it's straightforward. Teacher's name to another submapping, which is a list of students which is a number or roll, to their names. Oh, perfect. I am not wrong, I don't think, so that's good. Then create a mapping of trainer. See, I should have just copied and pasted that, but I'm just so used to typing things out on my other keyboard anyways. Trainer list with a key of map, hash map of address to trainer. See, I think I need to have the like labeled as something, but we'll see. Trainer and a value of trainer. Okay, we have trainer right up there. That's easy. So then trainer is that new struct we just created. So, I had a quick confusion of like, is it the same? But we already know from here that you just write out the Pokemon from the struct. So it's the same as right here. Write out trainer from the struct. Super easy. And then here we have our fun little nested mapping. So let's just go start it. Okay. Train Pokemon hash map. So, okay, we're hash mapping. See that still. Let's just look up here to make sure we're doing it right from the beginning. So yeah, hash map. The teacher's name. Because it's hexadecimal, so I think you can just write out address because it's just like a global thing for Vyper. It knows what that means, I think. And then comma is how you, I guess, differentiate that out. And then, okay, you hash map again. That makes sense. So we're going to hash map the address, and then perfect, comma, hash map. Oops. which maps to another submapping, and that's where you have the full mapping out. So the first mapping is just like how you key in like the first piece of information. So now you can put in an address here. So trainer to Pokemon is going to be a hash map. So it's going to be like you're going to be mapping an address to a mapping. Oops. Sorry. I need to figure out how to get my screen to be bigger. But anyways, to a mapping of, again, I don't know why I try and type anything out when I code anything. I hate typing when I code. I just copy and paste from the docs, from, open, like whatever. Just, yeah, copy paste that. Copy pasta, as one of my friends says. And a value type of Pokemon. So, just a little comma. And that should be correct. Let's see. Oops, I forgot the extra brackets. Let's see what else I might have forgotten. Let's look here. So I guess let's look at it here too. We have the hash map. There you go. But here, does it have? Ah, that's why. That's something I forget to do often. Here, it's actually a hash map. So you have the address, you have a comma, and then, if that makes sense. See, these are the things I enjoy going through like tutorials, because things that like I just don't remember from like just programming. I don't program often. I kind of just read code, and so my brain completely skips over stuff like that. Okay, that should be, and this is where I like removing this, so that when I go to, actually, let's try using this. Let's try using this. Oh, it seems like it's working. Let's see what we have different. Okay, seems like it's correct. But again, I'm not 100, so I always like checking this to make sure. I think I just switched, so that's going to confuse me. I just want to make sure it's correct. So my code, Pokemon list is there. So these are just switched. See, I spelled that wrong. So that should be correct now. Again, let's just double check here. Okay, so now it looks like I was correct. The main thing I forgot was spelled address wrong, and I forgot the bracket there. So, but to be honest, pretty simple to what we did before. Perfect. Let's move on to what message.send. I think we went through it above here as well. Now we have our mappings to keep track of which trainer owns which Pokemon. We'll want to update the contract functions to use them. In order to do this, we need to use something called message.sender. Again, like address before, we were able to just use the variable address, and like Vyper knows that you mean that you want to use the an address of the person, like whoever's calling the function, or the user calling the function, the wallet. Here, Vyper knows that when you use message.sender, what you mean is, again, the address of the person calling the function. Yes, not transaction origin. Message.sender. So does this, okay. In Vyper, there are certain global variables that are available to all functions. One of these is message.sender, which refers to the address of the person or smart contract who called the current function. Note, in Vyper, function execution always needs to start with an external caller. A contract will just sit on the blockchain doing nothing until someone calls one of its functions. I enjoy like these little notes throughout this tutorial as well, because these are things that are important to understand on the blockchain in general when you're trying to start programming on the blockchain is that um, blockchain is anything in particular. You can actually code something, and then external addresses have to actually call these functions in a smart contract, and that those transactions then get mined and put into a block, and those changes of state in those transactions is what causes the power of the blockchain, this immutable state. So this idea that nothing's actually happening, so there's always going to be a message sender in it. So if you have a smart contract, for example, you say, okay, only message, message.sender owns something. It's a great variable to use for security reasons, is because if you deploy a contract, you say, okay, message.sender deploys the contract and owns the contract, then you always know that if you own those keys, you deploy the contract, you're always gonna, there's always gonna be that variable. Or if you just copy paste your address and you end up, your cat walks over your keyboard, or my dog will definitely walk over my keyboard, and you deploy a contract with some ETH in it, because I always try and deploy contracts with ETH in the beginning because I'm just lazy, and then I'm ready just to go and with ETH in the contract. But then you're out of ETH, because then you can never own the contract. Anyways, here's an example of using message.sender and updating a mapping. So you have a favorite number mapping, which is a mapping of address. Again, we have another, I think, for sure, like a variable, global variable, to a number. So you have so say the address is me. So I have Chloethedev.eth would be, I think in Ethers, you can just put in ENS names. So if you're programming this, also, I guess, in Vyper, I don't know if you can use ENS names in Vyper. I have absolutely no clue. I'm assuming you can download a library and do it like that. But natively, I don't know if you can do that. Anyways, but if you could, you can go chloethedev.eth and then put my favorite number in, which is 19. My son was born on the 19th. Playing soccer, my number was 19. So there you go. If you were mapping it for me, you'd put my Ethereum address here. You would put my favorite number here. Boom. And then how would you get it there? You'd have a function to set that number. And then I would have to call, or someone, but me, would call this function. And I would say my favorite number is a number from 0 to very high. It has to be a positive number from 0, whatever. Yeah, so update. So here, we're going to update our favorite number mapping to store the number under message sender. Because remember, if I call this function, I'm message sender. So we are going to have a function, in this favorite number, which is up here, for this address part right here, we're going to have message.sender. Again, it's just very simple, equals my number, which is right up here, which is U256, U256, very straightforward. And then you have a function, which is a view function, an external. So it's called from externally, but it doesn't actually change any state on the blockchain. So you're just looking at stuff. Just looking at stuff. And so the function is going to be, what's my number? So you're trying to look it up. I think you have this free little, so you're looking up a number on the blockchain. Again, so very simple, from 0 to very high number. I'm not going to try and remember what that number is ever, because my brain will not do it until anyways. And so we're just going to retrieve the values stored in the sender's address. It'll be 0 if the sender hasn't called the number yet. So, and these are things that are important to know, in my opinion, because it makes programming so easy. And these are things that are simple to program. So if you know now that if I haven't called a favorite number, it'll return 0. So this is an easy way to figure out your membership. Is someone a member of my DApp? So if you have a mapping of, I guess for this it would probably be, is this address part of, have they called the function to deposit to my DApp, right? And you'd be able to look up that. When you look up their address, a number, right? If you got 0, you'd just be false. They have not deposited any money to this DApp in the past. And then because it's the blockchain, you just know forever. And it would be very easy, because it could just be an easy view function. You're not changing the state, and you could easily just call one simple function to look up. I'm not sure if that's the most efficient way of doing it, but it would work, I guess. And then Otherwise, it'll return the favorite number of the person, so otherwise it could return how much ETH that person has deposited to your dApp, so you could know maybe how much returns to give them if you're in a DAO or something, and you want to know, okay, how much ETH have you deposited over the term of this contract? We have this much money to give out, and so you divide that number over the total number of ETH you have, and then you figure out your deposit, the ratio of deposits, and there you go. You got a little way to hand out some DAO profits off a little Vyper function. Beautiful, beautiful. In this trivial example, anyone can call set my number and store a number in our contract which will be tied to their address on the blockchain. So if I called it as this function, message.sender would be me, and if I wanted to look that up, I can use Chloethedev.eth, and then it would call 0 if I haven't put a number in, or it would call 19 if I set a number to 19. Then when they call with a number, they would return a number that they stored. Using message number gives you security of the Ethereum blockchain. The only way someone can modify someone else's data will be to assert the private keys, which will be the Ethereum address. So again, this is the beauty of using all of this, is that that if you have your private keys secure, that no one could ever change that number. So again, it's pretty cool. Anyways, put it to the test. We need to update the contract functions so that we can create a trainer using the trainer struct and trainer list mapping. This function should also call create Pokemon function to create a Pokemon, and then use the trainer to Pokemon mapping to assign the ownership of a Pokemon to this trainer. Finally, we would increment the trainer to Pokemon count. So very simply, we're going to we're going to create a trainer using this little trainer struct. So the function, so say I was calling this function with Chloethedev, I'd be like, okay, my name is Chloethedev. So I put that into the function. And it will go into the trainer list mapping. So here we're going to map addresses, so message.sender, to this trainer, to my name, Chloethedev. So when you look it up, you'll see that if you put in Chloethedev.eth, you get Chloethedev, if I put that in for my trainer name. This function should also call to create Pokemon function. So that basically what's going to happen is, it's only an internal function anyway, so the only way to create a Pokemon is to actually call this function. And then it should assign that Pokemon to a trainer. So, and it's all happening in one function. So again, it's secure, because as you create that Pokemon, it's going to be instantly assigned to that trainer, and then you are going to be able to assign ownership, right? And then it's going to be to you, message.sender. And then finally, we would increment the trainer Pokemon count. And let's see. Trainer Pokemon count, which is a hash of addresses. So this is the count of total Pokemon trainers in the game. So we know that if you are going to start this game, you're going to put a name in. So Chloethedev. You're going to get a random Pokemon, and this random Pokemon is going to have random data. It's going to have a name. It's of 32 characters, and it's going to be a Pokemon. Right here. So the Pokemon's going to have a name. It's going to have some random DNA. It's going to have random HP and nothing else, right? So the matches are going to be 0. Wins are going to be 0. Perfect. And then, it's going to call this function Pokemon list and update that, which is up here. It's going to also call this function, which is what self means, and it's going to increment the total Pokemon count by 1. So all we're really doing is copying some of this stuff, and we're just changing some of these little variables, and so it shouldn't be that bad. So when it says create an event, we've already done that. So that's already right here, right? So, although it doesn't, anyways, we don't have the little green thing isn't here, but that's all right. We know where to do it. We don't need that. And all we have to do is indent to start our code in Vyper. So the event's going to be new. Again, it's already here, so I'm just going to do that and cheat, but I should have copied and pasted that. Um, it's going to have a single property to let you know that a new trainer was created with the name of, we don't know, but it's going to be a string of 32 characters max. And for names, I do enjoy the whole very long characters because you get to really, like for random Pokemon names, I guess it's not that big of a deal, but when you get to choose I dislike greatly when I'm playing a game and I'm trying to like put in like Chloethedev and it doesn't work. So, maybe someone has like, for Bianca, my fiance, I have like Dr. Sexy Chocolate Cream Dream Oompa Loompa as her contact in my phone, for example. Yeah, I want to be able to have some really long, cool names. Why not? Playing a game. Let's have some fun. Anyways, we're going to create an external function. So we've already seen how to do. Actually, we don't have that here anymore, but super easy. And we're going to do it down here. So to copy up there, right, you're going to have external. See, and this is why I don't even type out, because I don't have my little linter thing where I can just tab out everything. And for me, it's really hard to see things back and forth even when they're side by side. So external function named create trainer. So we're just going to start like this. Create trainer. So we don't need that underscore. So if you look up here, you try and copy that. There's a little underscore here, but that's because it's an internal function. So it helps you instantly know, okay, like this is an internal function. It can only be called by the contract. And here okay, there's no underscore. It's external. It can be called by like externally. So here you'll see it's external. There's no underscore, and we're just doing that. And I don't think it's view only, so I don't think we put anything like that. Named create trainer. There we go, which takes 2 parameters. So we are going to have it take the parameters of trainer name, which is going to be a string of 32 characters. I don't think I need this little. Oh, I do need this little thing because you have the 2 little. I think you need one of those 2. I'm actually not sure. And it's gonna is it gonna return inside the crate? It's gonna do all these things. Anyways, I know it's gonna take that and hopefully, yeah, we're just gonna copy and paste together. I can't see fully on my screen what the auto complete is saying because my screen is too small, so I can never tell what it actually is. It's going to be a string of 32 characters. So I definitely think, let's see how it's written out here. See, this is what gets me here, but you know what? Ooh, they have this at the end. Because we're not doing a little return function thing. I think we're like having that like this. So I guess I need this. Do you need that for the structs too? Yeah. So I guess that like instead of needing semicolons like you do in Solidity, you have it where you use these colons. Okay. So in this function, again, all you have to do is keep it tabbed. Does that for me? We are going to trainer and assign creative, which I think create trainer body, create a trainer struct. think I got the right structure for that. Yup. Struct trainer. All I get to do is tab it with the name as trainer name. I can kind of see it. Fine. I'll just go through with it. Create a variable. Oh, that's all we got to do. Okay, cool. Create a variable, new trainer. It's always different. When you, the one thing that confuses me is that when you create variables here, they're constant. But I get that makes sense. In Vyper, you want these to be constant variables that don't change. Whereas here, these variables are not constant, so you don't have to put that. Oops. That means we're no longer there. Inside, you're going to create a variable, new trainer of type trainer. New trainer of type. Do I just write it like that? Trainer. And assign its value to, is this how, okay, let's just go through it. As the trainer created, which is, okay. Is it here? Like, I guess it's that, right? This is the trainer we created, right? The new trainer is going to be this trainer's name that we just created in the struct, which is the trainer of trainer name. Cool. I don't think we need anything at the end here. I think we're good. Awesome. I think we can just go to the next line. Okay. Add the new trainer to the trainer list mapping by assigning message.sender to new trainer. So I think we've done that before. We're changing something in this contract. So I think we have to use this self thing. Sorry, I need some water. Like, throat's killing me. Okay. It's taken me a while today. It's been a long weekend. Thanksgiving weekend, which is wonderful. But it's been long. Been good though. We are going to add the trainer list mapping. Okay. So we are going to do self dot to the we're adding to trainer list mapping. And we're assigning message sender to new trainer. So I don't think we have to do self.pokemon count because it's not something in the contract we're doing. We're doing something that's a global variable, and we're making it equal that new. I'm going to act like I understand what's exactly there. Good enough. And we don't need anything at the end. Great. Makes sense, I think. Put a little space. Actually, I guess I won't. Add the new trainer and Pokemon to the trainer to Pokemon nested mapping. So that's up here somewhere. So self in this contract. Trainer to Pokemon nested mapping. So it's going to look similar to this, but probably more complicated, I would assume. Let's just figure it out. By adding two keys. The first key we're going to have is message sender, and the second key. So remember, we probably don't. It's probably the same like as before. So instead of let's just keep it as the bracket, and the second key as. So I need new brackets. that to is that I think which acts as a unique key for each Pokemon trainer, and the value assigned is new Pokemon. So let's just double check it looks like how we had it before, because that's what I remember it looking like, but I forget these things very quickly. So we have the hash map, or we had the where's our double? Yeah, hash map, bracket, number, comma, bracket, bracket. And then we come down here and it's bracket, comma. You know what? I can't remember. This is why I have to look at it back and forth so exact, because if I don't do that, I completely forget what I'm doing. Anyways, I think that's done. Increment the trainer to Pokemon count, which is something that's also in here. I love how I don't have to do any like at the end of that. Like just so simple, smooth. And then fire the new. Okay, so now we're just going to do the event. We're going to log a event called new trainee created, which is going to have the parameter of trainer name, which is right here. And that event was what we put up here. Where are you? Oh, is it not here anymore? We had 2 events. Maybe it's somewhere else. Where'd it go? Where'd you go? I'm assuming it just create an event. Didn't I just do that? I'm so confused. Okay, well, I swore I put it right here, but event, new trainer created, name, string 42. Okay, well, there you go. There it is. I might have put it in there twice, but it's there now. So, perfect. Easy enough. Next, wild Pokemon, time to 3. We now have trainers in the Pokemons. Every Pokemon fan knows that trainers go on tours and battle with wild Pokemon. If they win the battle, they catch the Pokemon. Simplifying such a beautiful game. Let's create a new contract using which we can battle with wild Pokemons and try and catch them. Put it to the test. We will reuse some parts of our previous contract. Now, we're reusing parts of our previous contract. We're creating a whole, we're going to very cool. So this is kind of explaining to you that now you're going to have a new contract where you're going to have a different set of logic. So in Solidity, for example, so I'm assuming it's not the same because before it said in Vyper it's 1 contract per file or whatever. So I'm assuming with Vyper it's to simplify things, you have each file being its own contract. So I would assume this is the first time we're going to a new contract. And so we're going to have a different set of logic for a different side of the game. So I guess this was the full contract logic, I would assume, for controlling the Pokemon creation. And I would assume that to have the whole logic of wild Pokemon, we're going to have a different contract. But I could be completely wrong, but that is my assumption. Add a constant UN256 storage variable. So again, it's going to be a global storage variable in the contract named name modulus and set it equal to 20. So this is going to be the wild Pokemon. And these are going to be, I guess, not how Pokemon are created in terms of when you create a new user account, but this is how you would battle a Pokemon beat it out in the wild and then capture it to find new things. So, for example, I just got added to the Dark Forest thing, but the whole idea is you do things on the blockchain, you take over things, and then you win something, and then you own that resource, that NFT or that token, or in any case. But you can have these wild random tokens, and then by winning them in a battle with your own Pokemon, you could win these random Pokemon that are created by the contract, by this different logic of this contract. Add name module is here. So I mean, we already know what the you just do this thing. So we're gonna add a constant story build. Ugh, can't really see it, but still gonna do it like this because it's a bit faster. Constant uint256 equals 20. We're gonna create a storage variable battle count. I wonder why that one gets to be gets the normal lowercase stuff and everything else gets to be, I like it, complete bold. But anyways, battle count, uint6, which is going to equal nothing. Wait, create a, okay, so it's not equal to anything, which I guess is, in Vyper it starts as 0 when you don't have anything there. Create a mapping with, oh, okay, sorry. Although either way, I'm going to remove those things because I think it's not going to, actually, let's just, add Pokemon names here. Oops, see, that's why I can't actually see what's there. Pokemon names. Constant. Ah, we finally got a little string in there. There you go. Pokemon names is going to start out equaling Pokemon names. Oops, nope. It's going to be whatever random value we create for this Pokemon name, right? Anyways, make the following changes to the random DNA function. So, I kind of want to go back to the other one, but I guess I would have to open it in a new tab. So here we have the generate random DNA function, which is taking basically it's randomizing the number and giving you this DNA with a maximum of DNA modulus, which is up here. Can only be the max digits of 16. Okay, so we're making changes to that same function. We're going to remove the name parameter so that it does that the random DNA accepts no parameter. Okay, so there you go. Then we are going to replace name with battle count. Okay, that's super cool. That's super cool. I like where this is going. I really like where this is going, actually. That's super cool. Now, you may remember from lesson 1, chapter 11, that KCAC 256 expects a single parameter type, bytes 32, bytes or string. So we need to use convert to typecast battle count, which will be a unit, uint 256, sorry. So a number from 0 to really high of how many battles this Pokemon has won. And you've got to turn that into, byte 32, bytes, or a string. So I guess you can do any of those, but I was assuming we're just going to go to bytes 32 because it's just, easiest. The data type for, oh, it's right here. Sorry. So, geez, I do not remember how to cast, but I want to try and see if I can remember how to do this little convert thing. We're we're just gonna try and see if I can remember how to do it. So, sorry. Oh, it's convert right here. Oh, that's no fun. I didn't even have to, like, you know. Anyways, let's look through it though. We're gonna replace name with battle count. So we need to use convert to typecast battle count 2 bytes 256. So yeah, battle count is going to be cast 2 bytes 32. Did I check to see if my last? Oh yeah, we're still on this one. You may remember from lesson 1, chapter 10, that we add pure to a function which does not read contract state or environment variables. But now, as generate random data is accessing battle count, which I think is super cool, but it does change what was happening before, so battle count is a state variable, something that is going to be changing. State variable, something that is, didn't I create a storage variable battle count? Did I forget to add it? See, this keeps happening. But at least I checked, right? That's all that really matters. And it was like that. I knew something was missing. Something was missing. I was like, gee, that didn't make sense. Okay. There you go. So that makes more sense now. But I think we may need self here because we're at, see, now I'm back on track. I don't think I even created this mapping either. Yeah, that mapping. Create a mapping names. Can't remember if this is the right syntax for this. We're just gonna do it and see what happens. Okay. It's one mapping, so only one. Oh, there you go. Sorry, a little more water. Okay. So we're going to take out pure. We're going to remove this, put that up. We're going to check the solution. So they have HP limit and name modulus. See, where'd my HP limit go? Anyways, we're just going to copy the, wait. So they have Pokemon names underneath. Wait, why do I have Pokemon names? I did my mapping wrong. Wait, why am I? Create a mapping, Pokemon names. Oh, did I just create? Sorry, that was 100% my fault. So Pokemon names, battle count. Okay, so just I was missing the HP limit, so that didn't come over from the other contract. That's fine. Does this shift enter let me do this? Nope. Can't remember how to, or I'm just gonna. There we go. Ooh, I did something wrong, I think. Okay, so I didn't need to have constant here. Oh yeah, because it's changing. Duh. That doesn't make sense. So yeah, the battle count of these Pokemon will change as these Pokemon battle. So that makes sense. And then here, the solution is saying it's not going to take anything. Make the following changes. Remove the name parameter. Oh yeah, they said that, except no parameter. I'm just not following directions. Remove, so it's no parameter. Okay, so when you call this function, it's going to generate random DNA. It's going to take in the battle count that is there as a bytes 32. So because this battle count is going to change for this Pokemon over time, what's really cool is that the random DNA should also change, which is super cool. Every time like when this function's called for this Pokemon. And I think that should now be exactly the same. Oh, I forgot the extra convert. So this convert here is ensuring that the hash of convert, so we're converting again. Okay. Ooh. Okay, sorry. I'm like realizing what I did wrong and what I took out last time and trying to put it all together to make sure I understand. So here, you're going to convert, you're going to make sure you convert the variable from this contract battle count, because that's what's going to be, it's always going to be a number. Like you're got, like, because this variable is in the contract as a number, it's going to be a number. So you have to, like, you got to convert this hash to a number, right? So the contract can use it. But then you got to convert this number in the contract to the hash, right? Because you can hash it. So here, is it at the end that I need uint 256? And that? Oh, I forgot the extra. I always forget brackets though. Wait. Jeez, I'm forgetting the. Oh, I added it here and didn't have it there. Man, that is, and this is where it would be fun to actually do this in. So I think I'm going to do this again eventually, and do it in do it on my actual like machine and actually go through the code and build it on like on the blockchain, at least on a test net. I think it would be cool to actually like go through these problems. Like here you have like the solutions. Yeah, so like you have this, which isn't actually like, you know, working, I guess, fully. But if I just ran through it on the like on my compiler or whatever, just ran it through, I would just see the errors and be able to go through it myself, which would probably be easier anyways. Anyways, we're done there. Let's pop over the next one. Chapter 4, the init function. Our contract. Okay, so now we start understanding like how to start a contract, how to actually some actual. So the first chapter was going through a lot of the variables we might use and like getting to building a contract really, and then we kind of finished it off really quick. And now we're kind of talking about, okay, now we're having more complex logic in these contracts. How do we actually start these contracts off? So our contract will create random Pokemons with each with which a trainer can battle with. So we need a list of Pokemon names from which we will select a random Pokemon for battle. So for example, you're going exploring the wilds, but how do you know which Pokemon you're battling to have that struct to make sure you know what's the Pokemon's DNA, what's their HP, and all their data. You have to know that kind of stuff. Anyways, we need a way to store a list of Pokemon names when we initialize our contract. For this purpose, we will use the init function. I love how it's so like blatant in Vyper, like what you're doing. I think it's the constructor function in Solidity. Init is a special initialization function that may only be called at the time of deploying a contract. It can be used to set initial values for storage variables. So these storage variables here, these ones have values, but for example, actually, where'd the other one go? Anyways, I thought we just had some variable that didn't have. Anyways, right now we don't. Wait, I guess battle count you could init and add, but anyways. Um, so usually use the init function to set message sender. So you can do, this contract, so self, their owner is going to equal the person who called this function to create this contract. And so the owner is a global variable, which is going to be address. So here you are using a init function, which is external, and it doesn't take any data here, but it's just going to make the owner of this this variable here, which is going to be an address, message sender. Very very simple, basic way of using an init function. Here we go. Very very obviously, I'm just going to copy and paste like this entire thing and use that. We will add up to 20 Pokemon to the init function. So we have to define it first. So we have, external. We're going to define def. That's what confused me when I started writing like Vyper and Python and all that stuff. Like, it's def mean. So we're defining the function, which is the init function, which is going to take in define init function, add the external, and add the following code to the function body. Here we go. All we gotta do is indent. You don't need to add anything else. Is that all we gotta do? It's gonna be Pokemon names, which is hash mapping a uint 256 to a name of string. So I think we have to say it's a string. I'm not sure though, but I want to check. I'm just going to put it there and then just check. It's nothing. It was fun to check though. It was fun to go through it. So I guess when you define it, you always define it as nothing, and then whatever. I guess because you can define different data types in here, that makes sense. Because you can define more than just strings. So if you define like a bunch of different things happening in this internal function, I guess you couldn't just put. But I guess you could put like string or whatever else. But anyways, I guess you don't do that. Darn. Let's make sure the rest of it right. See, I need to remove this so I can see it properly. There you go. Perfect. Wonderful. Okay, next. Create a random wild Pokemon. In the previous chapter, we initialized our contract with 20 Pokemon names. Now it's time we battle. And I think what will be cool, super cool, is like, so for example, the whole Starkware VDO thing. So it's like they use a VDO function, a verifiable delay function to compute a random number, I guess, and to put it on the blockchain. I thought it was every 3 hours. I think it's every hour now. But anyways, if you had this be a function that took in the data from the VDO smart contract, which I guess would be probably bytes 32, and then took that and you converted that into a string of, like, I guess between 4 and whatever characters, or you could have a huge list of names on a different smart contract that you kept updating, and then you just said, Based on the number. Oh yeah, and then tick up the number of Pokemon names on that contract every time you add to them, or it can just be something you control. But just a way to have this be variable, so that like you could have new cool Pokemon that like users in the community could like kind of like you could have a DAO contract that where token holders for this game are able to vote on new Pokemon names like once a week. And as those Pokemon names get added to this other contract, all you do is when you have um, generating a new Pokemon, um, instead of having it be, so you initialize with these 20 Pokemon, but when you create new Pokemon, just have it be a function that generates from that contract. So it'll be super cool. Super cool. Now, see, my tangents are completely for me, and that's why I call this Chloethedev Unfiltered. For those that happen to eventually watch this, definitely skip over all these parts. Eventually, hopefully, I'll go through and have someone like go in the comments and put timestamps for when I tangent and rant. But it helps me when I go back and watch these to have my tangents and know what my thought process is. Because eventually, I think it would be cool to kind of like create this for myself like on the main chain and I don't know, have a little fun, maybe play it with my siblings or something like that. So a function with multiple return values. A function can also return multiple return values like the following. So you're going to have a struct of student, which you're going to have the name, which is going to be a string of 32 characters, and age, which is going to be a number. You're going to have a mapping between roll number and student details. So you're going to have the student list, which is going to be a mapping of, again, number to which student, which is going to have the string, the name, and the age. Then you're going to have an external function, so called by an account or smart contract call. So again, it's always going to have a message sender and stuff like that. And you're going to define the function. So the function defined as get person details, which obviously is going to be getting these details here, which is going to take in a roll number. So what student number is it? So the number, and it's going to return a string, which is going to be obviously the name and then the age. So just the first one is the name, the second one is the age, first one's the name, second one's the age. So in this function, you're going to have student, which is going to equal, which is going to be the student's struct and equal, and go into this contract, sorry, student, go into this contract, go to the student list variable, go and then take a roll number, which is the number you're going to input into the function here. And then it's going to return student.name and then student.age. So student name, student age. Okay, so now we're going to do it with actual Pokemons. Cool. So create an external function. So we're going to define the battle function here. I'm just going to type it out so I can practice actually typing these things out now because I'm done trying to like battle that out. We're going to define a function named battle, which has one parameter. Pokemon. Per Pokemon of type Pokemon. Do I do it like that? I completely forgot how to declare that, but we're just going to keep going. It returns 4 parameters. Bool. String. Unit 56. And unit 256. And I'm assuming you're going to be like, did you win against who? And then I don't know how many wins and losses, but let's see. Inside the battle function, create inside the function. So all you gotta do is keep it here. And we're going to create a variable named random DNA. It's going to be a U in 256. Now call the generate memory function and assign its output to random DNA. So I think it would be self to call it. I'm tired of typing. I did it for a bit. I like getting used to the mechanical keyboard. I'm used to using like virtual keyboards and like all these different laptops and flat keyboards, but I just got a new mechanical keyboard, so I'm trying to get used to typing with it, but still make a lot of mistakes. Function and assign its output to, I think this is how it goes. I don't think anything at the end for this. Inside the battle function, so same function we're in right now, create a variable named, yeah, I'm tired of that, random name. Self. And then random name is going to be, oh no, it's not going to be self anything because you don't know it yet, right? Okay, string random name. Darn it, what am I doing? Oh, I need to create the variable first. That's why I was confused. Wait, I think I'm doing this wrong, but we're just going to do it up here so I can maybe understand what I'm doing. String 32. Now assign a value to random. Now to assign a value to random name, we have to select a random name. See, like I think that's why. To assign a value to it, we have to select a random name from Pokemon names, which is up here, which is taking this and the number and mapping it. So random name string 32 equals, I think I have to use self still, and I think I have to use Pokemon names. Let's just read it so I actually know what's happening. We have to select a random name from Pokemon names. How do we know it's random? So we have to use the whole mod and all that mod, yeah, all that fun stuff. So by passing any uint 256 from 0 to 19 is the key. We can generate a suitable random number by the following operation. Random DNA mod name modulus. Because we know that name modulus is going to give us a number. Sorry, so it wasn't a character from 0 to 20 of the name. It was a number from 0 to 20 giving you which Pokemon you were going to get. So you're going to go through this contract. I'm going to assume we're going to Pokemon names. And you're going to get me which value. It's going to be random DNA mod name modulus. And I think that should give us the right answer. So we're going to create a string variable called random name, and it's going to we're going to assign it to a value from this contract called Pokemon names. And which one is it going to be? It's going to be that hash. Is there a hash map? Yeah, there you go. The hash map of Pokemon names. And I guess it's interesting you can, yeah, hash map of Pokemon names. Perfect. And I'm going to remove Oh, we have one more thing to do. Is the battle function create a number? Random HP. I'm hungry now. Set its value equal to, sorry, UN 256. Set its value equal to, oh no, it's not self. It's just so self is when it's like a variable, like a global variable. Sorry, storage variable. So self Pokemon names, yeah, but here you don't have to use self. I'm pretty sure. Equal to random DNA, because that's right here. Mod HP limit, which is up there. So I think I have to use self now. I think I don't really know. I'll be completely honest. I don't have to add anything to the end. I'm pretty sure of that. And then I'm gonna. I thought I removed this. Okay, whatever. That's fine. Maybe I didn't yet. So they spaced it out. So I will space mine out so that I could read it well. Wait. Oh, sorry. I did. Oh. First of all, why does that? Okay, I did something wrong here in general. Why does it say in the title function create a value called random HP? Where's my random DNA function? Inside the battle function, create a variable called random DNA. Now call joint function and assign it to. Oh, I guess I should have just generate random DNA. I guess I can just do this. I wonder if it would work. See, this is where I want to like something like remix, where I can just like do it how I did it and see like would it work to create a variable and then in the same function at the end take the variable and do something else to it. It probably would. It probably wouldn't be very efficient in code writing. In my brain, I guess that's how I wrote it out. That's what I did. But yeah, obviously not very efficient. So let's just take that away. And then random DNA, generate random number. I'm just trying to make sure I have it all. So generate random DNA is up here. It returns a uint 256, which is this is. Perfect. I think something's wrong here though, and okay. Okay, so I didn't need, I thought that because I had multiple variables here. Oops, that's a solution. So because you have multiple variables here, you have to use parentheses. Okay. Sorry. Ooh, I have a few errors. So here, okay, so here makes sense. I just forgot to have this part in the random DNA. That's just my, that's my bad. I forget these things all the time. But what I think I'm a bit, and that's fine. I'm not going to change the spacing. I see it better with the spacing. What I'm not sure I understand as much is why you don't need the self here. I think that is confusing to me. Let's see. So we're looking at the HP limit. So self-generate, yeah. So it's green here. It's not the same, but I guess that's my one thing I would have a question on. You know, why I do not need, because I think we're looking at HP limit, which is a constant. in this contract? Who knows? Not sure though. I will. Maybe I'll like put it in the comment section so that I remember it. I'll come back and look at it later. I'll write it somewhere. Actually, I'm gonna write it in the comment section so that I remember exactly. Actually, I'm just gonna put it here. There you go. Good enough. I'll be able to go back later, watch that, and look at it and see what's up. Anyways, besides that, I think we're good. See how far we are. Okay, we're about halfway. Not bad. I think I was live for about 2 hours last time. I can't remember. Now we're at about, I think, half an hour or so. So, oops. Pretty sure I just closed my browser. So let's. Oh no, I just minimized it. Sorry. Getting used to using a Mac is new for me. Chapter 5. And we just did that. Chapter 6. Comparison operators and if else. So now we're getting into the juicy stuff of any programming language, but I'm sure it'll be fun in Vyper just like anything else. In the previous chapter, we created a battle function, which created a random Pokemon. We need to compare the wild Pokemon and the trainer Pokemon to return the result of the battle. So again, it's all algorithmic anyways. All these games are, and just the more fun your algorithm is, the more fun your game is. For this purpose, we need comparison operators. Comparison operators, different types support different comparison operators. For our use case, we will compare two numbers. Here is a list of comparison operators supported by Unit 256. You can do is x less than y, is x less than or equal to y, is s strictly equal to y, is x not equal to y, or no, I guess 3 is strictly equal to, then 2 is equal to. Anyways, is x greater or equal to y, and then is x greater than y. So very simple operators, comparison operators. Then simple if and else statements. So the if statement is a control flow construct used for conditional execution. So if some condition happens, we're going to do something. Condition is a Boolean or Boolean operation. So condition is a true or false, 0 or 1. The Boolean is evaluated left to right, one expression at a time, until the condition is found to be true or false. If true, the logic of the body of the if statement is executed. Note that unlike Python, Vyper, I like these like differences to like really show the differences what you, as someone who comes from Python, to really help me differentiate between the two. Vyper does not allow implicit conversion. Wait, I think I need to read this like perfectly. From non-Boolean types within the condition of an if statement. Oh, so you can't do 0 or 1. See, this is like, this is where it's important that like, I like this so far. So you can't just use, if one pass. You can't mix the two. It will fail with a type mismatch. So you have to use Boolean, I think, or use 0 or 1. I don't think you can just mix match the types that you use. You can also include else if or elif. Cool. You don't have to write out else if in Vyper. I'm used to writing out the whole thing. And else statements to add more conditional statements and a body that executes when the conditionals are false. Put it to the test. We will compare the HP of Pokemons to decide the winner. If the trainer Pokemon wins, the trainer gets the new Pokemon. Okay, so in this game, you fight another Pokemon in the wild. If you have one Pokemon, you beat their Pokemon. If you win, you get that Pokemon. So you can see how you could add some interesting logic where you could have a list of Pokemon and maybe a max of 3. You go out into the wild and you encounter random Pokemon. And they could have, you can encounter random trainers or random Pokemon or whatever have you. And it can just, take in the Pokemon's HP, and you could have some attacks that you do, some attacks that they do. When one Pokemon's HP equals 0. You can check which Pokemon's HP, which trainer that is for the 0 value, and then you would know which one lost at least. And then you'd go, okay, well the winner account owns the Pokemon from the loser, and then boom, super easy. We will compare the HP of Pokemons. Perfect. Inside the battle function, we are going to increment the battle count state variable by 1. I think I can do that one. Plus equals 1. Then we are going to create an if statement. So if what? If I'm not really sure. Oh yeah, so basically it compares the HP of the trainer Pokemon parameter and the random HP of the wild Pokemon. If the HP of the trainer Pokemon, so if the trainer Pokemon HP Pokemon, where is it? Pokemon HP. So I guess it's this. HP of the trainer Pokemon. How do I find the HP of the trainer Pokemon? Self. Yeah, it's on this contract. And then I know it's a Pokemon regardless, but this is going to be this. Return in the if statement return. So you're looking at this contract, okay? You need to compare the HP of the Pokemon self, or would you do the Pokemon and then see in my brain I'm looking for like the account, the account, the mapping of accounts to Pokemon. So my brain is just randomly like, oh, where is the mapping of account to Pokemon, trainers to Pokemon? Anyways, I'm just going to do this part first. In the body of the if statement, return the following. Turn battle result true. True. Random name. Random DNA. And random HP from the wild Pokemon. So it's probably if that return. I think I'm missing a lot of things in this one. Okay. I don't know why I'm having an issue here. So if this, do this, it doesn't say there's any else. Else nothing. I guess we're not having anything else. Just if you win, you get the Pokemon. If you don't win, you just move on and get nothing. Nothing happens at all. It'd be really cool if you had like a PvP type of thing where you put some like money into a pot and then you had it like if you win, you get this, or if you lose your Pokemon in it. But I guess it wouldn't look like this function. Anyways, which compares the. I'm just not sure how to get this data. And I feel like I need to. Okay, let's just look. Okay, so that was. Oh, it's Pokemon.hp. Hey, I'm so silly. I'm so silly. Anyways, that was one where I was just being a little bit silly, I think. Um, because obviously it's a global like variable of all the Pokemon in the game. So I don't need to look for the trainer's Pokemon because all the Pokemon in the game are the same variable. Duh. Um, and like I'm thinking like, oh, we have an array, and instead of using an array, we're using a mapping to map like accounts to Pokemon. And no, we're doing it with a struct. Sorry, I see. That's me not paying attention to the actual this actual code, and me just my brain just off on a different planet. Um, so yeah, that's where I forgot the self. So because here your battle count is a global variable, you will need to use the self because in this contract we're going to have the battle count, which is again a global variable of the total battles. Um, wait, cool. So this is all the battles that have happened. Um, in total. Cool, 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 cool. What would be interesting is I think it's really cool having that total battle number, and then you have the matches here. So you can I think it's really cool as now you'd be able to know like out of the total matches that have happened, and like, it was kind of interesting. But like in the total game at the time it's happened, how many matches has your specific Pokemon won? Um, like what's its win ratio to what it's played, but also how active has this Pokemon been in the game. So this game's been going on. There's been a thousand matches. If your Pokemon's won, 100 has had 100 matches and has played 10% of the game. It's kind of cool. It's been very active. Maybe it's been traded a lot. Maybe you could look into that. But if its wins are like are really low, maybe you can see okay, you played a lot, but its wins are low. Or maybe a Pokemon's been only played 10 times out of 1,000 matches, so maybe it's only played a little bit, but it has 10 wins. So its win percent is 100%. But now you're looking at okay, but out of the total battles, you only played 10 battles. That's not really telling me much. But if you've had 1,000 battles and you've had 500 battles and 400 wins, I'd be like, whoa, you've played half of the games or half of the. Okay, half is a bit too much. I'd be like, okay, you're like playing the same person over and over again. But you know what I'm saying? If you were playing a high number of matches in the game and you had a high number of wins, you could value this Pokemon differently. Differently, being like, okay, this Pokemon is worth having. So if these Pokemon were NFTs instead of being structs, you know, you have to have it be an actual tradable token instead of being something that's just part of the game logic. But yeah, we will compare it. Blah, blah, blah. I think it was, ooh, I did this wrong. But wait, now I'm a bit confused. Uh, in the solution, it's saying it should be a lowercase p, but I'm okay. So I definitely forgot this because I'm just silly at forgetting things. But I'm pretty sure you need to use Pokemon HP. Do we have a Pokemon variable where it's just we do here? Oh, we do. We renamed it. Ha ha ha. There we go. See, this is why I like it too. Seeing the solution, I can go back and remember. Okay, so we did rename it here. So I was looking for this as a global variable, but we're not using that. We have to use it as a state variable. And you do the same thing with Solidity, cast the variables and use them as a state variable so you can change it. So it makes sense. Jeez. I'm guessing the dog is playing. So we have the Pokemon here, HP. So you're able to kind of cast into this Pokemon and then use the variables here. Or is it? HP is greater than random HP. I wonder if you can keep this spacing here. because I like the spacing, but I'm gonna take it away because sorry, I'm not sure if you can have that. I'm not sure you can have the spacing in any programming language. I don't know what I'm talking about. Oh gosh. And you don't need anything at the end. Okay, perfect. Empty functions. I'm guessing this is what you send Ethan. Let's see. In the previous chapter, we defined the logic of a Pokemon battle and returned the wild Pokemon details of the trainer Pokemon wins. But what if the trainer Pokemon loses? In such a case, we need to return some empty values. Empty type name returns any. Empty is a built-in Vyper function, which returns a default value of the type name passed as a parameter. So this is the first time I've ever seen this before. So we're gonna get to this together. It is useful for initializing new memory variables. So if you have an additional function, you're going to find a function called sum function. It's going to take nothing. The variable is going to be name. It's going to be a string, and it's going to be an empty string. So basically, you're creating a variable. So this makes sense. This is how you would say you wanted to create a new Pokemon, like I was saying previously, with that whole DAO structure. You would be able to create a new Pokemon, a new variable called like Special Edition Pokemon 2020, and then maybe have, I guess, you would be able to, I guess, create like a mapping, because you could do any new memory variables. Let's see, all the types. Oh, maybe you can't do mapping. Not as fun. Not as fun. Okay, so you can do like numbers, strings. So I guess in addition to strings, you can do addresses, bools, bytes, decimals. Okay. Put it to the test. I guess you can't use hash map. Sadly. Be nice. We will use the empty function to return default values in case the trainer Pokemon loses. Create an else. Perfect. Okay. So if else, which returns the following values. Else, if this else, I'm assuming I have to stay in here and do this way. Else return. This looks weird. I feel like I don't like how it looks. Anyway, we're gonna keep going. Else return false. String wild Pokemon DNA. Empty. Is that the syntax for it? Oh, I guess it is. Nice. So let's see, that should be correct. All we were adding was we used the empty function, right? Empty string. So that's what we kind of copied and pasted and kind of went over a bit too quickly. So this is the empty function, which is a function that comes with Vyper. So I copied and pasted it, kind of quickly went through it, but we're using this function to create a empty string for this whole idea of because when you battle, you're gonna take in some variables, but you're gonna get nothing. It's gonna be false, for the win, and for these units of what you get, empty. It's just nothing's gonna happen, and that. Ooh, nice. I knew it looked wrong. So I assumed that going out here was wrong, but I couldn't tell what you. But then the idea is you use that. Oh yeah. So for me, I think the hardest part is remembering like okay, I don't need to use these bad boys anymore, but you do need to use these at the end of some lines, not others. It's like structs and stuff like that. Oh yeah, okay. That looks correct. Correct. That one was pretty straightforward. Interfaces. So this is how we now are going to hopefully connect a couple of these contracts. In the previous chapter, we completed the contract for the Pokemon battle. So that was just the logic for battling. That's not really the main logic of our contract of like creating trainers and keeping track of all the trainers and stuff like that. Remember the first contract where a trainer owned a Pokemon? It needs to interact with the Pokemon battle contract. For doing so, we use interfaces. So like interfaces are like pretty much the way you interact with all of the smart contracts in Ethereum. So for example, if I wanted to interact with, just that's how you do it. An interface is a set of function definitions used to enable communication between smart contracts. I like, see, that's much better definition than I was giving. See that? That's why I like going through these things live. So even I can remember and go through these things and have a more defined or a more concrete definition of what I'm talking about. A contract interface defines all of that contract's externally available functions. So this allows you to easily know all the functions that are in a contract without having to read through all the complex logic in them. And it can be kind of dangerous, like, this function's called, convert F to die. Let's call that. But in the actual logic, it could be something completely not what you want to do. Let's say, you wanted to convert F to die. So it's important to not only, look at the interface when you're, coding these things, but also make sure you look at the actual contract code. But this does help when you're trying to do things quickly and make sure you can use functions from other contracts as long as you declare the contract. So, by importing an interface, your contract knows how to call these functions in other contracts. So for our use case, we need to create an interface for the Pokemon battle. Sorry, I crack my back. The trainer contract. This will allow the trainer contract to communicate with the Pokemon battle contract. So now we're going to connect these two contracts and how they interact with each other. Using interfaces. Interfaces can be added to contracts either through inline definition or by importing them from a separate file. Okay. The interface keyword is used to define an inline external interface. So if we're going to add an interface here, we're going to go interface, and then, it's not going to be car. So let's do this first. I'm getting ahead of myself already, just coding the thing instead of just going through the tutorial. Typical. Interfaces can be added to contracts either through So if you have an interface of car, so this contract car is going to have the function start and the function get speed. So you can start your car. So a different contract called car has a function called start it. So you can start your car through this. So true or false. I guess it's checking if the car is started. And I guess non-payable, so you can't send any ETH to it. You're just checking. Is the car started, I suppose. True or false. And I guess if you went into it, it would probably be just like a getter function of true or false. I was getting the state of something on the blockchain. And then again, same, get speed would just be view function, just returning. I guess why is it this one view? Maybe bools can't be viewed on numbers and strings. I don't know. Get speed. You're just viewing the state of the blockchain, and it's going to return a number. So it kind of gives you a lot of the information about what this contract is doing. This contract is clearly about cars. It clearly helps you know if the car started, and clearly helps you know the speed of the car. So if I actually call this, the actual logic might be something completely random. But at least I know I can't send F to it. So there's something I do know. Same here. This get speed function could not really show me the correct speed of a car. That doesn't mean that's what it shows me. I could look into the logic. I have to actually see that. But what I do know is that I can't change the state through this. and all I can do is view the state of the blockchain. So there are things you can know definitively, and there's certain things where you can't really know just from the interface. The defined car interface can then be used to make external calls given a contract's address. So you do need the address. You do need the address of the contract, but you're going to call the driver. You're defining a function of driver, which is going to go to some address and call the address, which I'm assuming would give you you're calling the car function contract at some address and start. You're checking to see if this person is a driver in the contract, I suppose. I know this is so at the address of the contract, you're going to take in an address for, I guess, your person. So I guess me, I put Chloethedev.eth or what my address is. It could be message.sender, like check yourself, but you wouldn't want to check. So if I want to check if someone's a driver in the contract, I go to the car contract, go through the actual contract of it, so the 0x long hexadecimal address, and call the start function, which is here, which will give me a bool, true or false, of, I suppose. Okay, so yeah, the interface car can also be used as a type for storage variables. You can then assign an address value to the variable to access that interface. So this is how I guess you would normally do it. You have a variable called car. I think we did it earlier with we referenced a variable. So you have a car, which is going to be the contract name, so that's why you have sometimes it confused me all the time. Like, why would you have a lowercase and an uppercase? That's so confusing. It's just because this is the exact name of the contract. So where? Yeah, I'm confused. Where's the name of this contract? Shouldn't the name of the contract be up here? Okay, I'm a little bit confused. That's all right, though. Anyways, the name of the contract is car. Why am I so confused with this right now? Anyways, let's keep going. The name of the contract is car, but the variable is going to be car. And then you're going to have an external function. You're going to define an initialization function, which is going to, so when you start this contract for the very first time on the blockchain, when you deploy it to the blockchain, you're going to have a car address, which is going to equal some external address that you've put into you deposit. So if you had if you were like, hey, we're going to initialize this trading bot, and we're going to initialize it with the MakerDAO address, let's say, or the Uniswap address or whatever, and you just copy and paste the Uniswap address from Etherscan. So if you're like, we're going to initialize a contract with the address of Vyper.fun, you'd go to Etherscan, you'd hit copy address, you'd come back here, and in this part here, you just paste the address, and you could, for example, have that be, and then you, for example, if you wanted to change this address in the future for Vyper.fun, you'd have a variable to change. It doesn't say constant here, so I guess you'd be able to change it. And that's the whole point. It can be changed because So and then you have an external function here. So I'm assuming it can be changed. Can this be changed? That's a question I have. You have a variable up here that doesn't say constant. Can you change it? I would assume you can't, actually. That I don't know. Now, say I want to bring out my remix. Actually, I think remix has. Okay. Now I'm getting excited. I think remix. Last time I haven't used remix in so long. Again, I don't enjoy writing in Solidity that much, but I'm pretty sure Um, Remix has Vyper. Is this? I see a V. I'm just gonna. Man, what is this? Can I just like see like a simple way of Solidity compiler? What else we got? Let's just type it in, eh? Vyper. Okay. I'm like, okay. Let's compile Vyper contracts. Okay, so we are going to. I didn't know I could do this. Because then I have a lot more space and I can show a lot more of the screen and I can just copy paste from the tutorial onto here and actually runs the code. And that would make a lot more sense. So Vyper, okay. Local compiler, please. I'm already on that. Local compiler, wait. Not use it for production. Oh, yeah, that's what I want. I want them to compile, for me. Create an example. Compile. I've never used this before, so I just want to see. I'm sure the flow is very similar. Where's the issues? It's giving me errors, but I'm not seeing them. Ugh. Or wait, do I interact from? Man, I'm so used to using this. Oh, oh, dude. No compiled contracts. You have no. So yeah, shouldn't it? What? I'm so confused. Does it not? Okay, I should probably just like. Okay, so I have this Vyper contract. Obviously, I can't compile it with the Solidity. Can I just remove this? Like, I don't want this here. It's so confusing. Dang it. I just want to remove. How did I add? Oh, I went to the plugins and I to deactivate. Deactivate, and all I want is Vyper. Do I have to set like um, owner? Maybe I can't do this because I need a. Okay, voter with delegation. You have voter. Maybe you need to have an init function with global variables. Chairperson, message.sender. Maybe I'm not logged into MetaMask. I am logged in. Wait. Is it using MetaMask? Gosh darn it. No contracts compiled. I click compile. I'm just going to hit local compile and see what happens. Still doesn't compile. And I don't see any error messages. Maybe I'm just not reading this. Check transaction details to start debugging. How do I get to that in here? Did it even create a transaction? Yo, I want more information, not less. Yeah, it's not even logging anything here. This is. I really want to just do this in like properly, but I might have to. Oh, yeah, this is okay. Let's also. Maybe because I don't have like all the information I need to have here. Let's see quickly if we can. Do you? I'm guessing you need this in Vyper. I'm guessing that's not enough, but I don't think I even have. Sorry, I'm gonna. Um, sorry. Okay. Interface. Then. Okay. Sorry. um, why won't it compile? What is this? Okay, I give up. I'm gonna try and figure out this week and maybe next week for chapter cancel. Maybe for chapter 3 or whatever, I'll be able to get that done. I really wanted to kind of just be able to run some of this stuff in actual compiler, and so that we can actually kind of see some of these errors instead of having to always check the solution. Be much easier now with a lot better. Does not seem like I can get Remix to work with Vyper. Okay, so we're using interfaces. We're talking about how we can use the car, specifying payable or non-payable indicates the call made to the external contract will be able to alter contract storage data, whereas view pure call will not. Okay, so non-payable, I guess in Vyper you have to say what it is, do you? Where are we? Yeah, so everything has something. So this one's pure, this one's view, this one's non-payable, this one's payable. So it's explicitly written out what type this function is. What I think is really cool because I don't like not knowing what type it is when you're going to call it. It's that's kind of part of the information you need to know. Can you send ether to it? Can you change storage? Are you just looking at the blockchain? And is it a pure function where you can't change anything and do nothing and it's just like random and yeah. Additionally, payable allows non-zero value to be sent along with the call, meaning you can send ETH when calling a payable function. So no, view and pure call use static call. So that's a opcode in Ethereum, ensuring no storage can be altered during execution. So that kind of explains it very clearly. But the way that works is by using static call, a specific opcode, it securely ensures that when you call these functions, storage isn't changed. So putting it to the test in our actual Pokemon contract now. As the coding area can only have one file at a time, we have removed the Pokemon Battle contract and added the trainer contract. So it's switching back and forth, but that's why. You can check out the Pokemon Battle contract here. And I guess I can just oops, that's from last time. There we go. Oh, cool. This is easier too. Just kind of having it. Although I need to make that like, where's the night mode? Oh my gosh, my eyes are blinded. Gosh. Sorry. Sorry, I guess everyone's seeing all my. This stuff isn't that important. Count. Man. Where's just like. Ugh. It's blinding me. Oops. Let's open that again. Oh my gosh. Trying to blind myself, but here it is. One, the Pokemon Battle contract only has one external function, battle. So when you look at it and you go through, it's very easy to see. This one's internal, so we're not going to be using that. This one's internal, not going to use it. But this one is external, and it can be called from another smart contract. So this is the one we're going to be writing the interface for. So here we're going to be adding in, oh, it's right here. So that's very helpful. That's very nice of them. But the way that works, so I gotta write the code. Wait, I don't think we need this battle code. But anyways, Um, as the battle function alters the state of Pokemon battle contract by adding data to state variables, you will use the non-payable annotation. So that's why you're going to have an external function. So this is the function. We got to create the interface for this function. So I think we have interface, which is going to be, what's the contract? I already forgot the name of the contract. See, this is is this just battle contract? The battle contract. See, this is where I think I'm getting confused because I'm not understanding like what's the name of the contract. But like here, interface car, we have a car contract. Here we have interface, I guess it's the battle contract. And so here's the contract having capital letters, but let's just start with that. Interface, see, sorry, this is, I'm just trying to get the interface, whatever. Oh, they said what it was called over here. Like, oh, we took away this. We removed the Pokemon battle. We're just gonna call it that. Okay. Interface Pokemon battle. And I guess we could also do it for us. They do not do it. I was saying we can create like a variable called Pokemon battle to an address, like you have it up here. Let's do that. So we're gonna have Pokemon battle, which is gonna equal, I think you can just now say it equals Pokemon battle. And then you're gonna have like external function that you define. Again, this is not even going to be in the solution. I don't even know if it's right, but I'm just writing it out anyways. Init, and then you're going to init the Pokemon battle contract. Poke battle. I don't know, man. I don't think it. To define growing recipes to make external calls. Address is going to be self, and then we're going to go to Pokemon battle, and then equals Pokemon battle at the address of, let's just do this, Pokemon battle address. Perfect. And now I'll be able to use this variable, Pokemon battle, which, I mean, I should have, yeah, whatever, as the address. So now when I want to call a function, I can just call Pokemon battle dot battle. Yeah. So I think I did the entire thing. No, I didn't finish the interface. So interface, let's see. Interface, I think I can use a lowercase of it now. Oh no, I didn't even define the interface for it yet, right? Yeah, that's just changing the address. Interface for Pokemon Battle is going to be. I still think I can use. We're just going to write the interface out. Battle, which takes okay. And what can this function do again? Oh, I think I wrote it out right here to make it easier. This function battle takes in a Pokemon and returns a bunch of fun stuff. So returns, and we're just gonna these are all basic ones, but I'm assuming again I'm gonna need these. Okay. Okay. As the battle function alters the state. Sorry, I need to actually create this Pokemon. So I need to call that function. Wait, create a Pokemon. Does that mean battle a Pokemon? I'm assuming it wants me to battle Pokemon. I'm just gonna try battling. So if we were battling a Pokemon here, we would go to the Pokemon battle contract, right? And what you would do is you'd call the battle. So instead of having self, right, we would do something in this contract, the Pokemon battle contract, which we know is Pokemon battle, which we initialized as being this address, which would be, which would be an actual hard-coded address. So, so this, for example, would be on Etherscan somewhere and an address, and you put 0x1 and then some rand. Or you could, for example, what would be better if you had an ENS name and you had a library, it could be like pokebattle.eth, and then I guess that would also work. Then you're going to create Pokemon here. You're going to Pokemon battle, Pokemon battle. Sorry, dot battle, like you have here. Instead of having to do this kind of thing, I can just do what I did, dot battle, and then it's just gonna return whatever you defined in the interface. You need to be able to take all those things. Create a Pokemon. Yeah, I think it means battle. I could be wrong. Very well could be wrong. So battle a Pokemon, Pokemon battle.battle, would go to this function, call battle, and it would take a Pokemon, and I guess that would be the Pokemon. Oops. The first Pokemon. Which Pokemon is it using? If Pokemon. Yeah, here we go. It's taking in a Pokemon. So when you battle, it's taking the one. So I guess we're assuming that trainers can only have one Pokemon, because this is always going to take your first Pokemon. I'm assuming. Or I guess if you had something that could take in which specific Pokemon, because it has to take in the Pokemon. Sorry, it has to take in Pokemon. which is going to equal the Pokemon struct. Very interesting. So when you call this battle function, it's going to want the Pokemon, but how does it know which I'm just thinking through it in my head of different ways that I might like go through this, but how does it know which Pokemon I mean, obviously it's using the Pokemon that I had in the first one, but I'm thinking through like how you would have a mapping and have it so that you could either pick which Pokemon you were going to use to battle. So maybe like you were able to see the Pokemon. So maybe you could only have 3 on your like when you go out to World Wild. So, but like when you see like let's say Charizard and you know its stats, you could pick which one of the 3 you wanted to use to fight that Charizard. So sorry, I'm just thinking of complete different logic here. Add an interface named Wild Pokemons. Ha ha ha. See how I wasn't. Again, I did it again. Interface called Wild Pokemons with one function definition. See, why didn't I just go to the end before I started coding it? See, why did I do this? With a non-payable annotation. So that's what I forgot. What I forgot was to make sure I added, death battle. So I feel like, do I not need all that? Oh, okay. So first of all, let me just take away this because this is confusing me a little bit. So when I define this interface, let's do one more. When I define this interface of wild Pokemons, I'm defining the function battle, and right? But in the interface, I thought I do need that in the interface. Sorry, I'm like confusing myself right now. Oh no, I'm being silly. Silly, silly, silly. I do not need all this. I just need to put. Wait, yes, I do. Gosh, darn it. Sorry. I need this, and then I need to add this non-payable notation. I'm pretty sure. Sorry, go back. What did I do here? I think I did something. Sorry, my screen's really small. So. Non-payable. Okay, that's what yeah. My bad. So when you have the interface of whatever the contract name was, so the contract name is Wild Pokemons. So I should go up here and call it Wild Pokemons. And then I'll go Wild Pokemons. And here I'll go to self Wilds Pokemons equals Wild Pokemons at wilds Pokemons.eth. So you would have a contract deployed at wildpokemons.eth. Okay, that would be the address, and the contract name would be Wild Pokemons, and it, with all capitals. With capital, I guess not camel case. Sorry, capital in the front, capital in the back, and then the variable here, self, in this contract, all lowercase, Wild Pokemons, is how you're going to define it as Wild Pokemons. There you go, and that, and then when I have, we're going to call Wild Pokemons, and in that function, we're going to call, it's right here. We're going to call battle, which is going to take in a Pokemon, right, in the Pokemon struct, which is right here. And it's going to, take true or false and all this wonderful data. Did you win? Did you lose? all that kind of stuff. So that should be correct. Let's look at the interface first. So my interface should be exactly the same. Interface wild Pokemons. Ooh. Did I define it right? I think I defined it wrong. I didn't add this part to it. So it does need to be the entire thing. So when I wrote it out, I did copy and paste it exactly, but I was assuming that when you call it, it'll just take whatever data you had in. But no, you got to copy the interface exactly as the function was defined in the. So let's look at the full contract. You just copy and paste the full thing. And I guess I did know that. It's funny, like when I do it on like using like Open Zeppelin and stuff, I definitely just like, I guess there you kind of have it already. Like you just copy. But again, usually just copy and paste what you need and go from there. I think I need to have the external there too. Yeah, so interface, you're going to define battle, interface, define battle, random Pokemon, and you copy exactly. And then this function down here, it's not going to be the same lines, I don't think, but I guess mine's going to look different. So I have wild Pokemons dot battle. But what they have is let's see. You have nope, it's not here. Nope, it's not here. Where is the function? I'm in the solution, right? Oh, it just added me to add an interface. So why did I think I'm gonna I can't go back and see. I'm gonna refresh the page, I think. Because it said to do something. I'm gonna refresh the page and move on. Here, create a Pokemon. Oh, it's just there from before. I'm thinking it's saying to go and battle. And I'm already like battling, creating a battle function for some reason. My gosh. I don't really know what. I feel like I was supposed to call the interface. Here. I think it's supposed to say, battle a wild Pokemon. And I think I was supposed to do what I did and call the interface I created and have it do that. When I look at the solution, I do not see that function. I'm guessing it's going to be added, or maybe it's just a different chapter 3 or something like that. Okay, assert. Sorry. In the previous chapter, we added wild Pokemons. Oh, maybe it's going to be here. Maybe I'm just silly. Yep. As always, I'm going way ahead of myself. Woohoo! In the previous chapter, we added wild Pokemon interface to return a contract. In the next chapter, we'll start writing the function to battle with wild Pokemon using the battle function in the wild Pokemon interface. In the current contract, when we call the create trainer function, a new trainer is created with a single Pokemon. Now a trainer should be able to use their Pokemon to battle with wild Pokemons. If the trainer's Pokemon wins, the trainer captures the wild Pokemon. If they lose, they get nothing. Assert. The assert statement makes an assertion about a given condition. If the condition varies to false and the transaction is reverted, it's important to know. So you can kind of go through some logic, and you can be like, okay, assert that message set address is message.sender. Message.sender equals owner, for example. And that's a very easy way to be like, oh, if you're not owner, revert. Don't even do the rest of this code. So here, you can give an optional error message. So if you have a function that's apply for a driver's license, which takes in a name and an age, you could have the assert right away that your age is above 18. And instead of wasting all your time executing anything after that, you could say, hey, you know what? If you're under 18, Let's not waste our time because this is our optional error message with a little comma and whatever. Not eligible for driver's license. Very simple. Here, if the age provided for apply for driver's license function is less than 18, then the transaction gets reverted and the message not eligible for driver's license is displayed. Note if a transaction is reverted, then any changes made to the contract state by the transaction will be canceled. In other words, the state of the contracts will be restored to the state of a transaction before the transaction occurred. And I went through the Ethereum beige paper, I think last week late, I think a Friday or something like that. And this is kind of what I explained it a bit there. How, when you submit a transaction, if there's any part that leaves the transaction in a, what's the word they used? Not eccentric. Oh gosh, these big words that I try and keep track of. But basically, if the state is something that's not expected, it will not allow it to occur, and it will revert to whatever state changes you made to the EVM. It'll just revert back to zero after nothing happens at all, and just move forward like that. So put it to the test. A trainer can battle, capture, and own multiple Pokemon, so a trainer has to choose which fun. This is the mapping I was looking for before. So trainers have to choose which Pokemon they want to use to battle with the wild Pokemon. All Pokemon of a trainer are stored in the Pokemon to trainer mapping. So example, even to some fun stuff would be like, when you go look into your mapping, you're only able to choose, between a random assortment of your Pokemon. And each time you go battle a wild Pokemon, or you're given a random assortment of 3 Pokemon to choose from to battle. So you got to have some kind of fun algorithm logic to go through the game. And that's kind of where you could take a game like this, code it for fun, have all that, it's all done for you, and then add some stuff to it slowly to create a project to show some people or play or have fun with, which I guess what I might do. I'll probably do it for fun. To select a specific Pokemon of a trainer, we need 2 things. The address of the trainer calling the contract, which is easy because you got message.sender. A number index that will choose a specific Pokemon of the trainer. You may recall from chapter 2, which is this chapter, that you can get the address from they're talking about here, like lesson number 2. You can get the address of the contract's caller using message.sender. Create an external function. Add battle wild Pokemon function. Here, perfect. Add an external function named battle wild Pokemon, which takes a single parameter. Pokemon index of uint 256. And let's see. Oops. And it's actually going to have some logic to it, I'm assuming. Okay, so the trainer who calls this can pass Pokemon index. Ooh, so you can pass in which Pokemon you want to use, right? And so, for example, if the UI only showed you Pokemon index 0, 5, and 10, and you just have an assert function, so let's just say you had assert that, let's see. Assert that Pokemon index is equal to 0 or equal. No, you need to have the whole thing. So it'd be fun to be like 5, 3. So you could have a variation. So I mean, I don't know if you can do conditional things for assert statements, but like, so I would like to enjoy like, you know, so if random number like block dot timestamp, so now pseudo random number. So if pseudo random number, mod, you know, whatever. So if you get like a 0, assert that what they chose was 0, 3, and 4, or 5, and if they got a 1, assert that the Pokemon total was 1, 2, and or 4. And the whole idea would be that you'd have some pseudo-random, an easy pseudo-random way of choosing, having some fun variety. So as long as the UI showed the correct Pokemon of choice, you would then be able to say, okay, you know what? You can only choose from these 3 Pokemon. Assert this. Oh, you chose the wrong one, and you could say, sorry. You could not choose any Pokemon. You could only choose the 3 shown in the UI, and that would be a way of someone knowing, oh, okay, I can't just cheat. But the UI would do it for you. Click the Pokemon you use, the UI would show, oh, but if you tried to like hack in the back end and change what the UI said, it would say, sorry, no. The Pokemon you chose needs to be index 0, 3, or 5. So you can assert that in the UI on the front end, but you could also assert it in the blockchain, which I guess what's more important than no, I don't really care what the front end. You gotta assert it here. I should probably just go to the bottom because I'm just not really reading anymore. All the Pokemons of a trainer are stored in the trainer to Pokemon mapping. So let's go find that in the code. Here. Nope, not here. Trainer to Pokemon mapping. Perfect. To select a specific Pokemon of a trainer, we need 2 things. The address of that trainer, and then the number that we choose as the index for which Pokemon they want to use. So again, if you only have 3 Pokemon and you pick the 5th Pokemon, it's not going to work. So we're probably going to have to assert that the number you choose is going to be lower than, or between 0 and how much you have. You may recall that you can get the address using this. So we're going to create, sorry, I was already down here, I think. Sorry. Repeating myself. Create an external function which does that. A trainer who calls the function can pass Pokemon index, so that's what they want. Now suppose the trainer has a single Pokemon. Let us examine the following lines of code from create trainer. You're going to go to this contract. You're going to go to trainer to Pokemon. You're going to go to this address of who's calling the function. And you're going to take the variable in this contract from trainer Pokemon count. So that trainer's Pokemon, you're going to, for this address, right, because you're going to do the hash, you're going to the mapping, and it's going to equal a new Pokemon. Then you're going to go to this address, you're going to go to the trainer Pokemon count for this message sender, for this person, and you're going to equal 1. So this would be code to increase the amount of Pokemon. So you're going to give a new Pokemon to this trainer. With this, a new trainer is created and given a Pokemon. Yeah. The value of self trainer Pokemon count for message sender for the trainer is 0. The reason it's 0 because you have 1 Pokemon. So before it was nothing, there was no value. Now the value is 0. You're creating this value. So the first Pokemon is added to the index of 0 for the trainer to Pokemon mapping. As we increment the trainer Pokemon count, subsequent Pokemon are added at higher indexes. So the first Pokemon you create is added at 0 index. Then you tick it up by 1. The next time you call this, or this thing happens, it's added to that index of 1, and then you go here and you tick it up to 2. The next time you call it, you're doing it at the second index, and you come here and you tick it up to 3. Pretty simple. As we increment trainer Pokemon count, yes, we already talked about that. What happens if a trainer with a single Pokemon calls battle wild Pokemon function with a function Pokemon index greater than 0? Well, I guess on the actual blockchain, I guess you would always lose. It would probably just throw an error, but you'd always lose because you'd have an HP of, or some logic of a lot facing off logic of nothing, and you probably get an error. Maybe it would return a 0 and you'd lose. Either way, not very good user experience for the user. They're wasting gas. They're wasting all this logic and for no reason. That's you might as well save the user some gas and some user experience like flow, and just stop them right off the bat. To mitigate this solution, so it gives a runtime error. So there was no Pokemon associated with index greater than 0, so it won't even let you get there. I love that. I love the blockchain for this reason. You get a runtime error because the blockchain is like, this doesn't make any sense. The blockchain is like, there's nothing here. It's not a Python thing, it's a blockchain thing, and you can't have values that don't exist on the blockchain. Cool, I like that. That's what I'm talking about. Whenever you get exceptional, exceptional. When you get exceptional values on the blockchain or exceptional occurrences in the functions, it reverts, which is great. So to mitigate against this, so instead of getting an error or whatever, inside this function, so we're gonna, so the assert statement that I already created for something random that has nothing to do with this project. Let's just, what did I just do? Assert that Pokemon index is less than, where are you? Less than, okay, let's just copy and paste this. So we're making sure it's going to be less than the count. Because remember, you're going to tick up this count before you've actually, where did I put that? Like, I'm already losing where I did things. So self total Pokemon, let's just go here. So it's simple. So when you have the self Pokemon count for the message sender increasing, you're increasing their count when they haven't actually had Pokemon yet. So by doing that, you're making sure it's less. So for example, if you create one Pokemon, your index is 0, and your like trainer Pokemon count will be 1. So as long as you're less than 1, you're valid. But I guess it should be greater than 0. It should be greater than, like, it should be a valid integer as well. And I think you should be able to assert that as well. Because, I mean, you don't want a number that's less than 0. So, like, I guess, can you do greater than equal to? So Pokemon index would be greater than equal to 0 and Pokemon index, I'm not sure. You can do it like that. But I don't know. Maybe you have to do 2 asserts. I don't know. But either way, I guess you want to assert Pokemon index. So the number that you're choosing for your Pokemon is greater or equal to 0 in general, because you have to have a Pokemon. You have to actually put a number in. And we're going to assert that the number that you're choosing for the index, index is less than, so if I have 5 Pokemon, my trainer Pokemon count is going to be 6, and we need to be the Pokemon which is less than 6. Beautiful, beautiful, beautiful. Check the solution. Oh, so we should put an error. We should always put an error message in. So let's do that. Error message. I think we have to do. Is that the? Wow, you don't even need any of that stuff. Vyper is so much simple. I'm like thinking I have to do more to the code to make it work, but I just need this, and I gotta say, Pokemon index must be like valid. Uint less than, so it would need to be a uint, I guess 256. Let's just, whatever. That's less than total Pokemon. Where'd this go? Less than trainer Pokemon count. Must be a valid positive integer, including 0, that is less than trainer Pokemon count. I'm just going to add that in there because that's how I'd want to see a message error message laid out for me. Then I can be like, oh, okay. So for, whoever's calling the function, I can go into the contract and check what my trainer Pokemon count is. I probably have a getter function to check I can have a getter function to put my address in and check my trainer Pokemon count and be like, oh, I have 3,000 Pokemon. Because maybe the UI doesn't show me that. I don't know. Not every UI shows all the important information. Or maybe it does show the information. So anyways, not everyone uses a UI for every DApp. So having the data there is helpful. Okay, solution is assert. Okay, let's just make sure my function's correct. You're going to have, I forgot the self both times. That's something I'm going to have to get used to with Vyper. I do enjoy the self, and I have to ask the question of when do you, explicitly. I'm pretty sure you always use self when it's a storage variable, and then when it's in memory, you don't have to use self. But because Pokemon index is I don't even think we have it here. Let's see. Did it say make the Pokemon index with a single parameter? So yeah, it said create an external function, battle wild Pokemon with a value of Pokemon index, right? Which is a number, but where is that number? Let's look at the solution. Can you just, isn't it a mapping? Wouldn't it be a mapping to Pokemon? Oh, battle wild Pokemon. Yeah, I'm not sure. Assert that Pokemon index is less. The Pokemon index is a value you're taking in the function, you silly butt. So it's obviously going to be. Oh yeah, the solution doesn't use self. Sorry, that's what I meant. I literally said it out loud that you only use self when you have a variable that is in here, and I'm sitting there looking for it, knowing that it's not a variable that's in storage. Self total. So no, what I meant was, oh, sorry, I did do it properly. I just added two things instead of one, and so I was confusing myself. It's right here, Pokemon index. And this is why I'm saying, even for my brain, unless I have it completely laid out side by side as being exactly the same, I kind of get confused at what I'm looking at and if it's right or correct. Seems like it was correct. Now we need to call a contract. In Chapter 8, we added Wild Pokemon interface in the training contract. In this chapter, we will call the battle function. So I already kind of did that. But let's see. Is it still here? Is my code still here? No, my code isn't here. And so I'm probably just gonna skip this one. I'm gonna go through it, but I'm not actually code it through because I'm just gonna go to the bottom, and I think I already pretty much I will read it through though, because I think a lot of the information here is very valuable. And so I think a lot of the tidbits and the way it's laid out, I'm just gonna read through it. In Chapter 8, we added this. If you recall, we need a contract address to interact with wild Pokemon. So that's where I was saying if you had wildpokemon.eth as an ENS name on Ethereum, you could have put that there. We will learn how to deploy a contract on Ethereum blockchain and then get the contract in the future lessons. So here on Etherscan, you can get a contract address, boom, hex, so that works. And to deploy Again, that was just an Etherscan, not Etherscan, sorry, in Remix, you hit that deploy button, or test blockchain or whatever. But for the purpose of this chapter, I have deployed the Wild Pokemon's contract on the Rinkeby testnet. So this is a lot better. So now we can see it 3 days ago. Pretty cool, very recent. You can look at the contract here. Sorry. Ooh, no one's played with it yet. We're gonna have some fun. I'm assuming no one's played with it yet. Let's see. Let's make the world open source, not payable. Couldn't decompile. Maybe because it's not Solidity, it's trying. Unusual jump destination. Recompile. Jump. I'm trying to understand these things, but trying to understand what's it called? Assembly? Oops, did I just close my tab? Okay, history. Let's reopen that tab. And I want to go to this contract. Sorry. How do we get to interesting? Sorry, this is going to be fun for me. Sorry. This is as good as it's getting for me, I suppose. So I'm assuming this is where we use Kekak each time. So this, like, honestly, if you want to, like, okay, so this is how I learned to start, like, looking at opcode if you really wanted to. So this is the entire smart contract, and so it's not going to help us right now because we don't have the contract beside us. But if we had the entire contract, and it's probably here, if I go to Vyper.fun and I go to assets at final, and I go to what contract am I looking for? They said that, which contract is this? The wild Pokemon. So this is the battle contract, I think then. Sorry, I have random papers open and stuff. Sorry, I'm opening, the battle contract. So here we go. So this is the battle contract. And so we have a struct of Pokemon. And so you have a struct. And so on Remix, obviously here I can't tell what's happening in what order, but on Remix, you'll be able to follow along. Let's say you had this deployed on Remix. I wish I could show this stuff on Remix, but you can jump through each line of code, and it'll show you here in the opcodes, like what's happening and where. So you can think, where is it jumping in the code? Where's memory going where? And as you call different functions in Remix, I want to do all this in Remix so I can do all this live. But anyway, it doesn't really matter. Using the contract as the interface, you can make external calls to the interface functions, which we discussed in Chapter 8. I'm not going to go through this example because it's pretty self-explanatory in my opinion. We already went through it. Handling multiple returns using a tuple assignment. Unlike Python, you cannot directly declare tuple types in Vyper. However, in certain cases, you can use literal tuples during assignment. For example, when a function returns multiple values. So you have an internal function here defined with get, name, and age. It's going to return a string and a number. And for some reason, the number can be negative. That's stressing me out a little bit. Or do empties have to be? Okay, so I don't know. I'm not sure why it's instead of uint, but it's all good. Maybe when you, anyways, we're gonna have an external function, so call from an external account or smart contract defined as get person. it's going to make it a name. It's going to be a string, and it's going to start off as empty. Oh, so this you're going to have age, which is going to have empty. Oh, maybe because empties have to be ints, right? Because it's not a number, it's not a zero, it's not positive, so it can't be a uint. And instead of taking up all the data of 256, you just have an int that could be anything. Because when you take this, you're going to set it to something. So right now it's age, but when you create this, it could be anything. So you got to make sure. Okay, that makes sense. Number the return value of get name and age is assigned using a tuple name age equals self get name and age. So you're going to call that function within the same contract. Can also skip the parentheses. So that's parentheses confuse the heck out of me. Whenever I can skip them, I like to. So name age equals this contract and get name and age. So cool. But yeah, let's actually put it to the test so we can actually do it with this. It makes a little more sense. So we're gonna add wild Pokemon up here. The battle function returns the following 4 arguments. Bool, true or false, did you win or lose? New Pokemon name, new Pokemon DNA, and new Pokemon HP, getting tired. Inside Battle Wild Pokemon, define these. So, Battle Wild Pokemon. In here, we're going to define these 4 function variables and initialize them using the empty built-in function. So we're going to create these variables, right? Yeah, we're going to define these variables. And so this is where I'm saying you're going to have them be its. So when we do this, all we got to do is, it seems like we could do more if we're explicitly defining them. Interesting, because, okay, here we go. We're going to have bool. Sorry. Battle results. Pokemon DNA. New Pokemon HP. Yeah, I guess I don't need this with me as I'm going through this. I could just have this on a different screen and be coding it larger. Maybe I'll try that next time. So that, cause it's really hard for even me to see. But on a bigger screen, when I play it back, I can read it. So that's kind of, for me, it's helpful when I watch it back like this. So we'll see. But all we have to do here now is say battle result is going to be a bool, which is going to equal an empty bool, I assume. New Pokemon name is going to be a string, 32 characters, and it's going to equal an empty string of 32. I'm assuming I need 32 in there still. I haven't checked, but that's all right. For DNA, here it's saying again it needs to be a uint, unsigned integer. So I'm gonna keep it the same, even though it kind of confuses me. Again, then if you do empty, why would you do empty anyways? Anyways, we're gonna keep going. Uint 256. Maybe I'm misunderstanding something. Which is going to equal an empty uint 256. Oops. And then Pokemon HP is uint 256 equals uint, empty uint 256. Okay. Define them. Define a constant address storage variable. Nice. Now we're going to, I want to space in between this assert and that. Now we're going to add a constant address storage variable named wild Pokemon. So it's going to be called wild Pokemon, and it's going to be constant, and it's going to be address, I think. Yup. And it's going to equal the address we got. I'm just going to use this so I know it's the fresh one. That's probably right, but still. Copy pasta is the way I like to roll. No semicolon needed, I don't think. Beauty. Do anything else? Nope, I think we're good. Inside the battle wild, let's take this up. Oh, Mika's finally drinking. The dog, I'm so excited. Inside the battle wild Pokemon, use wild Pokemons. I guess that's going to be, okay, first of all, let's space you out because I don't need that. Use wild Pokemons, nice, and wild Pokemon to call the battle function. Okay, use wild Pokemons and wild Pokemon. Where's wild Pokemons again? Sorry, I'm saying it out loud. I'm talking about this one. I'm looking for this one. To call the battle function that takes a single parameter of typed Pokemon. This parameter, okay, so I know that we're going to have a battle function, and it's going to call, to take a parameter of Pokemon, and you attain it some trainer to Pokemon using the hash map. I'm passing the two keys. This is actually quite confusing for me. Message sender and the Pokemon index, right? So you're gonna battle, and then you go to not self, but you're gonna go to wild Pokemon is a constant address. I'm just gonna say it's wild Pokemon. Self wild Pokemon. You're gonna go to this contract and go to wild Pokemon, which is an address. Okay, go to that address and call the battle function, I think, which is gonna take in the trainer to Pokemon mapping with the key of message sender and Pokemon index. Use the function variables created in step 1 to create a tuple in order to handle capture the multiple return values. So that's what we have down here. And then bool string 32 UN256 UN256. All of these things are going to equal what we now have in this contract under battle. I don't think I need to put anything there. I think I can just leave it like that. So we're gonna check. So I think you should be able to just say, okay, you don't need parentheses for these variables. They're gonna equal whatever you got in this contract now for battle. And now you have data in this contract for battle because you went to this contract at this address, at some other address, and you called, oops, the battle function with the data of this trainer's Pokemon, this trainer, and whatever Pokemon index they deposit. So you're going to take in the index, go to that Pokemon, and fight. Sorry, I'm like having a lot of issues with my screen. Oh, so I have a mistake. At least one, probably many mistakes. Sorry. Battle results. Where's the battle result? Why is there battle result? Oh, I have to use their actual names. My bad. Okay, sorry. That was just me being, I don't know. You want the actual values that came from here. I know. So you don't want random stuff. You want the actual, the actual Pokemon DNA value is going to be returned here. And the actual Pokemon HP, new Pokemon HP, oops, shoot. That value is actually going to be returned, and you're getting the, okay, that makes sense. And then, for some reason, this, okay, I wrote that out completely wrong, but let's still, oops, let's take that out. Okay, so I just have an extra space. Okay. Another, oops, simple issue. There's obviously something I'm missing. Ugh, I keep doing that. There you go. I knew I was missing something. Didn't look right. There you go. What I am not understanding is, what did I have this here for? Self dot, because it says here, inside the Battle Wild Pokemon function, use wild, and this is what I didn't use. I didn't use wild Pokemons. So I want to see where it's called and where I'm missing it. It's inside the Battle Wild Pokemon function. Use wild Pokemons. What? Oh, sorry. Wild Pokemons. Ah, there you go. There you go. It's just the name of the interface. I knew I was being silly. Use the interface to call the function. So I think it was just saying, well, I still need to call it, right? So how did they call it? So if you call Battle Wild Pokemon, no, yeah, there should be something here, right? Like this part? What am I doing wrong? I feel like I'm missing the call. Create trainer. Because, yeah, battle wild Pokemon. Oh, maybe you can just call it normally. But I thought you need to call this battle function somewhere. And I'm not seeing that. I think that's where I'm confused. Oh, I see it. I see it. Sorry. There. I need to make it equal to this. Yeah, that was my problem with having a small screen. I had the code, but it's actually telling me it's equal to that. So what it's saying is, oh yeah, didn't I just do that? Like, yeah, I did that already. So why am I acting like I don't know how to do that? I just did it. Where did I just do that? That's hilarious. I can't even remember where I just went through that, and now I'm sitting here like, oh yeah, no, I did it here, and then it equals, yeah, sorry. And then can you just call self.battle? Whoa, I have it completely wrong. That's okay. That's really cool. I wanna see what it's supposed to be underneath. Let's see. So you have to go to, so that's why I was saying use wild. So here, when it says it, it was giving us the answer. This is why I kind of feel like I was calling it incorrectly regardless. Instead of self wild Pokemons, you're using the wild Pokemon's interface. Um, so I guess that's how you do it. You use the interface, you put it in parentheses, and then dot. So what function are you calling on that contract? Wait, sorry. What function are you calling? Battle. In that function, you still got to use self. Nice. So to now you know that the function you're calling, trainer to Pokemon, is in the battle contract. And then in that, you're going to use message sender. Oh, is it a nested mapping? This chat is a bit in the way, but it's all good. Oh no, it's not a nested mapping. You just, instead of using a comma, you gotta do it like that apparently. Okay. Nothing too crazy. But I do continually seem to be making that similar mistake where I keep putting things on a different line, thinking that logic should be going parallel instead of just equating things. And I want to test it out because I wonder if that stuff would work. Like, could you just write something on one line equals to something and then just write on something? But obviously, I had to use the interface here. Yeah, because you have the wild Pokemon's interface here, so you got to use this interface for what address? We did this already before, but for the address of wild Pokemon, and use the interface for that, and the function that only one that we have is this battle function. So putting it together. Okay, one more drink and we're almost done. Okay, sorry. Gosh, I've been live for 3 hours. That is insane. It's been 3 hours this time. I did not realize it was this long. Okay, putting it together. As we discussed, we have two conditions based on the battle result variable. If battle result is true, that means the trainer's Pokemon has won. Otherwise, the case of false, Pokemon is lost. Create an if-else statement, right? So you're completing the function body. So if condition, with the condition as battle result. If battle result is true, I guess equals true. Can I use that, or do I have to use like a one or something? If battle result equals true, let's use a capital T for that. Then that means the trainer's Pokemon has won. Otherwise, in the case of false, okay, create an true, increase the number of matches for the trainer's Pokemon by 1. So yeah, I'm gonna need a mapping and all that. Use the +1 to access the Pokemon. Are we back in the other? Anyways, trainer, Pokemon. So trainer to Pokemon mapping. And that's in this contract with the first key as message sender and the second key as, see, I can't tell if I'm supposed to do it like this now or like I just want to do it like that. I just want to look. See, yep, I knew it. Whenever you're looking it up, it's like that. So that's what I'm used to. So yeah, from Solidity, just do it like that. Anyways, self dot whatever, and then the assignment. I keep forgetting the assignment. Increase. Wait, what am I trying to do? Ugh. Increase the number of matches for the Pokemon. So take this Pokemon and then matches. Oh, dot matches. So you want to get the matches. I think that's how it would look. Increase the number of matches, increase the number of wins. So let's just copy that. And then instead of taking the win matches variable, take the wins. So if you've won, we're going to do that. If you've lost, why does it have this? Oh, self. Create a new variable named new Pokemon. Of type Pokemon. Create a new variable of type new Pokemon of type Pokemon and assign its value to a new Pokemon created using the Pokemon struct and use the following parameters. Can I do it like this? Name, DNA, HP, matches, wins. Create a new Pokemon. So it would be in here. If you win, we're going to create, I think to create a Pokemon, I have to call it. So Where's that create Pokemon function? Oh, here it is. Create Pokemon. So call this contract. I think you can just call dot create Pokemon with the parameter of Pokemon. I think because that's going to take the name or whatever else you need. I wonder if you can do this. New Pokemon equals. No, that's not going to work. Oh, maybe assign new Pokemon equal to that. Create a new variable named new Pokemon of type. I know I'm doing it wrong. It's kind of frustrating. Yeah. Yeah, why? Oh, it'll. No, I think I'm still confused. Because saying create a new variable, okay, name new Pokemon of type Pokemon. So I guess you're just saying that you're creating another struct with the, instead of having to type it out, you can just write Pokemon and say, okay, that's, and assign its value to a new Pokemon created using the Pokemon. I think that's where I was getting confused. I'm just going to look at, yeah, so you're assigning it. This is where I was getting confused. So yes, I get it. You're creating a struct, but you're actually like, you're just labeling out what the struct is. So you're using the same, this is quite, you're using the same Pokemon struct as before that you have up here, except you're using it. So like this is where like sometimes things get a little convoluted and a little bit confusing, but all you're doing is defining things explicitly. So this is the specific Pokemon we're creating right now. This is the layout of the Pokemon struct that's we're getting the data from. And this is the actual variable of the new Pokemon. So it sounds a lot more complicated than it is. You just take this data, you put it in here. So the name of this Pokemon is going to be the variable, new Pokemon name. The DNA is going to be new Pokemon DNA. And this is all data we have in this function, so you don't need self. HP is going to be new Pokemon HP. Matches will be 1 because you beat this Pokemon, but it just had 1 match and it lost. Wins is going to be 0. So if you also wanted to track losses, you go like losses, and you'd be like 1 because Pokemon just lost. I think losses are pretty interesting to track, but I don't know. It doesn't really matter. You have wins, so you know, like matches played, you have wins, you have losses without having extra storage in the blockchain for no reason. You know that if you have like 1 match and 0 wins, you can just do the math and subtract your wins from your matches and get like -1, or sorry, losses equals 1. 1 minus 0. Okay. Add this new Pokemon. Okay, this is where we're gonna have some fun. We're gonna have a Pokemon list mapping. So it's self Pokemon list. We're using the key of total Pokemon count. Let's see. Go to this total Pokemon count, and you're gonna add equals right, because you've increased count. Self Pokemon list. Let me look at the Pokemon list first. Where is it? Here it is. The Pokemon list is a hashing of numbers to Pokemon. So you're gonna add total Pokemon count. Oh, the total Pokemon count maps your address to all the Pokemon you own. So you're gonna add this. I'm still kind of confused. So you're going to the total Pokemon list for this person, and you go into the total Pokemon count. But aren't you just... Oh, I get it. You are going to the total Pokemon list, and for that new index of total Pokemon count... Oh, my back. Sorry. When I get confused, it's like the silliest things too. Increase the total Pokemon count by 1. What happened just now? If this self dot total Pokemon count plus equals 1, add the new Pokemon to the trainer to Pokemon mapping. So let's go to this mapping. Trainer to Pokemon mapping. The first key is message sender, and this, oops, the second key is trainer to Pokemon count. So second key is how many Pokemon this message sender has, and new Pokemon. So now, so here you're going to the Pokemon list, right? And you're adding this Pokemon to their list. Then you're increasing the amount of Pokemon they have. Then, for which Pokemon they have, you're making sure it shows up there as well. So you're kind of just keeping the state of the contract, making sure you update everything logically, keeping the logic all in one place, all secure and such. Increment trainer Pokemon count. So first you're incrementing the total Pokemon count in the entire game. Now you're incrementing just the trainer Pokemon count of this individual person, this individual user, or it could be a smart contract or anything, but this account by 1. Then if battle result is false, so if it's true, and then we figured out that we just had to do, can I just do else? Else, increase the number of the matches for the trainer's Pokemon by 1. So we're going to take self, here. I think I messed that up, yeah. Okay. We just copied and pasted anyway. Congratulations, you completed chapter 2. Tweet about it. I still can't see the tweet about it thing. But what I can do for the last time is I can, inspect, go to the bottom. Oops. What? Oh, here it is. Oh, sorry. If I do this, last time I was able to find it, just coming into here and using this. Perfect. Gosh, I'm gonna have to do that because it's gonna mess me up. What? I can't remember which goal that was. I think it was goal number 2. So goal number 2 accomplished. My 2 favorite emojis. Sure. Cool. Let's go back here. Let's check it to make sure we actually did it right? Before we like get ahead of ourselves. Gonna have to. I think I had a mistake already. I see. Oops. Okay. Sorry. Okay, so they have a space. Here we go. Yeah, typical me again, the exact same issue I had before. Not using that, and then the else needs that, right? So if battle results, what? Oh, so they're saying if there's any value. So if there's any value to battle results, right, at all, then execute this logic of, it seems to want self-trainer to Pokemon, self-trainer to Pokemon. Oh, did I delete that one by accident? Oh, sorry. I didn't mean to Control X. I meant to Control V. Okay. We have. Ooh, wait. Is there? I made the same mistake last time. You have to use. I think. You have to use commas. Yeah, you have to use commas when you make this. Actually, you use commas all the time with structs, right? No. So yeah, this is why I get confused. When you make the struct, you don't have to use commas at the end of the lines when you are declaring the variable. But when you are setting the variables, you need to use commas. And I made a mistake last week, and I also made a mistake here, not using commas. Just mix matching those two things. And obviously, this one does not need a comma. Yeah, it's just me being not really. This is where I hit the run 50 times, and I'm fixing all my endless bugs at the end of when I'm coding. Okay, so I need self here. Yeah, again, just me forgetting simple things. In my code, I don't have a space here. Let's see. And then, okay, so they added the log. Was there a log here? Okay, so you want to log that that makes sense. You want to log a new Pokemon was created when you win, because maybe that is in the thing. I just didn't do it. Let's see. If you win, log that you made a new Pokemon with this data, right? The specific data sets here. And maybe you wouldn't. So, for example, if I was logging this, You don't need, first of all, you can only use 3 data attributes usually, I think. I mean, Solidity was 3, so I'm assuming it's 3 here for event logs. But the thing is, the 3 most important pieces of data when you create a Pokemon is these 3 things. You don't care about the match because it's always 0. And the wins are, the matches are always 1, wins always 0, 0 or 1 for matches, but still. You want the 3 most important pieces of data when you do events. But yeah, I think I did want to continue double checking my work and making sure it looks, making sure it looks exactly. I'm missing something up here. Oh, sorry. Yeah, see, I'm looking at the wrong code. Okay, because I don't have the spacing. Sorry, I should see exactly the same. Again, I don't have the appropriate, oh my gosh, the appropriate spacing. Oh my gosh. There we go. Now we can check. Any discrepancies? Yes. Again, I forgot a self. I do that. So this is one thing that I'm going to have to get used to as I mean, the compiler will find these errors, especially these self errors. I'm assuming the compiler will definitely find. Yeah, I like my spaces between numbers. I'm going to keep those unless it causes some sort of issue. And I think that's it. Let's keep double checking just to completely make sure. And then, yeah. So that is chapter 2 completed. I'm going to end this video here. I am super tired. But hope anyone who ended up watching that learned something new. If you watch the future, hope you learn something new or whatever. So yeah, I hope you had fun. Hope you learned something. I'm probably going to I guess hopefully go live for the Modern Day Foundation soon. And go into CryptoVoxels, then hopefully come back and go live going to the Casper paper. But yeah, hope you had a wonderful time if you end up watching this, and hope it helps. Hope you end up playing the game, Vyper.fun. Oh, and this time I forgot to add the link to in the comments. So now whoever comes can just click that and get started. I should put chapter 2 here. But people can just get through.